Okay, we have, I think, argument that one thing. Yeah. Yes, other things. So, okay, so good morning to all. So we start the session, morning session with Diana's talk. Diana is so Diana Ivanova is an associate professor at the University of Brest, France, since 2017. She has worked in information retrieval, natural language processing, AI, including evaluation metrics, multi-document summarization, and has been a PI of projects on text simplification, AI for education, and automatic humor analysis. She has participated in the organization of various conferences, workshops, and evaluation campaigns. This year, she leads two play tracks, simple text on scientific text simplification and Joker on humor detection, translation and generation in English, French, Spanish, and English. So with that introduction, let's see welcome.
Thank you very much for the invitation and for the introduction and for joining everyone. Thank you for coming here on the last day of the conference for the first day. This is amazing. Courageous from your part. So my talk is entitled "My Smart Tools, Critical Minds: How Users Shape the Reliability of AI." I will present the work we have done at the University of Brest with the collaboration of the University of Amsterdam and the University of Bern in Russia. My talk is about around two things. It's about critical thinking in how user LLM interact, how users can detect hallucinations in LLM generated text, whatever means hallucination. And then we'll also talk about different biases that can occur in the generation but can be induced by our prompts. As you know, we need a new information revolution. Before there were multiple steps, and with ChatGPT, we have a new era of information access with new challenges about trust, about information manipulation, intellectual property, which was already discussed before, the value of creativity. We also talked about cultural colonization and the unity of the Western culture of others. But in my talk, I will concentrate more on the trust in AI and can we really trust in AI and can we trust in the users who use the AI, as well as the cognitive biases and biases that can be introduced by our prompts. So the first part is user LLM interaction. We have talked a lot about hallucination before in this talk. What it means, we will not give the definition. We can understand it as errors produced by AI. But we sometimes we know the ground rules, sometimes we don't know. However, these hallucinations, even if they are not well defined, have real consequences in the real life. And it can be very costly, it can cost money, it can cost life, it can cost health, it can cost related. Our question would be, are users able to apply critical thinking when they interact with LLMs? And the first research question is how well we can identify factual errors and authoritative and reliable sources in chatbot responses. This work was done mainly by my engineer Petrodakis, and we published that at the Yale conference this year. So when we try to answer this question, we also try to measure what kind of proxy we can use to identify how well people are engaged in critical evaluation of the content. For example, how do user behavior, for example, time spent on the task, the number of follow-up questions that keeping the sources to show the critical thinking area. What exactly we have done? We did a user study and we asked people to summarize the topic that we are made better decisions than humans. And we provided also a simulated chatbot. What does mean simulated chatbot? It means that we have never used AI. We have never used LLMs. We just pre-written 60 question answer pairs with introduced errors. We had different kinds of errors. We had factual errors. We had true false sources. We have also sources with false level of credibility. For example, for some credible sources, we attributed a very low credibility for the vice versa. And we also introduced different kinds of presentation errors. For example, we highlighted true information as false and false information as true. And we try to match the user questions to one of the questions we have in our database. We didn't have a lot because we did manually, and we choose the answer that responds the most to the way of the user. So there were actually two participants who told us that our chatbot was very limited because it felt there was it cannot answer this kind of question. Of course, we have only 6 years for the flexibility. So why we decided actually to simulate not to use the real LLM? Because we can guarantee that it will be the same content for all participants. We can deliver the errors and we can control which kind of errors we know what exactly was wrong and we do not need to update them. We know what is true information, what is false information, we can control everything. And we provided different versions, 12 versions, to see the impact of the different presentations on trust and critical thinking. This is the example of the interface. So we have a text box where you should write your answer and you can ask questions about about the topic, the chatbot, and you have information in green if it is called true, and in red if it is false, with the sources and the level of trust for each source. We did our study with 80 participants from different countries, but mainly France and Croatia. The majority of participants were between 18 and 30 years, or more or less equally spread between men and women, and with 5% of other genders. And the educational level was 65% master degree or PhD level, and 45% declared that they use AI as professional or academic work. We did 3 types of survey. The first was a self-reported survey, and we asked participants about the demographics as well as how exactly they use the AI and how they share the information. So what we found out that out of 80 participants, 35 claim that they are experiencing using AI, and 45, a little bit more than half, claim that they are not experienced at all. So, 8% who claim that they experience trust personal experience. We see that they check the sources according to self-reported 6 times more than people who are not experienced. They ask follow-up questions. So they actually try to get information and have more details than people who are not used to use AI. They claim to ignore sources 3 times less than the people who are not experiencing the AI. We see the same trend, for example, here. They trust less to the name of the sources. There was one person who prepared search engine, almost nobody said that it is actually important to check the sources. There is only 4 people out of 80 who said that it is important. There is 0 people who said that they are speaking the AI to completely trust the AI. However, there are 4 people who are not experiencing AI who said that they trust LLMs 100%. What we consider to be the type of critical thinking. So we are not in the mind of the user, but some signs of this critical engagement. If users correct errors in the chatbot responses, even if they are not highlighted, we think that they actually read the content produced by our simulated chatbot and actually they try to define the information. If they think about the reliability of sources or identify errors in the original information, we also consider that as a sign of critical thinking. And if they ask them follow-up questions to better understand the task, it shows also some kind of critical engagement. What we have discovered about people control this type of critical engagement, the interaction times was almost 3 times more with the chatbot that people who didn't control the time of critical engagement, 6 minutes over 2 minutes. The number of follow-up questions about critical thinking users was 4 and 5 seconds. So 4 and 5 questions compared to non-engagement 3, so twice more. Now it is interesting. How many times people actually click on the source? The users who show critical engagement click on the source in less than 1 time per user in average. And if you look at non-critically engaged users, it is 3% over, more or less. So, nobody. Somebody just clicked by error. How we can figure out by error because the time spent on this was at least 0 seconds. For engaged users, it is 4.5. So basically, what people here where this thing goes, but nobody actually did it. This is all the technical document. So the duration of interaction is number of questions asked, and at least on the source can be somehow reliable to evaluate continuous flow to the the five parts how we manually analyze the user behavior. For example, we manually check the something that was used. And what we know over 25, 15 experience and 20 non-experience didn't notice mistakes in the process. So half of people do not see errors if there is an error in reference investigation. There are actually people who ask questions of the topic that the AI couldn't answer. There are also, of course, for example, the main topic was about AI and made, and people ask how to prepare a student. So they actually tried to evaluate the capacity of our chatbot, and they complained after that our chatbot was used. There was 21 14 non-experience and their experience to meet the errors in source. So when we claim that the source was technical while it was technical, not trust and vice versa. There are certain people who ask follow-up questions, and we can see that experience in AI ask for follow-up questions 3 times completely more in the chat with the chatbot. The distribution correctly identified the wrong information was more or less equal with slightly preference here. So we have 10 person who correctly identified errors, factual errors in the information, and 7 non-experienced. There are 15 who just copy pasted the results without thinking what was wrong. We just copy pasted the answer of our chatbot. There are actually 15 who copy pasted the response of our chatbot, but they removed the false parts that were there. There are 50 people that say that did a comment about the credibility of the sources. There are 13 who didn't provide a summary. 8 people clicked on the sources, over 80 to 10%. And there was also 5 persons who correctly identified true information, which was labeled false. Now we know that because they said that we had a problem in the highlighting of the false information. And there were people who actually did the summary based on their prior knowledge or example. It was not related at all to the answer of our chatbot. And there were also 5 students interacting. The conclusions that we have, only 10% of you clicked on, which is somehow worrying. 35 used more or less half did not notice the source of the error. Nobody checked. Nobody there. 9 users placed too much trust in the source. If you claim that the reliable source and something sounds credible, they will trust. Highlighting of the text actually was a critical engagement. People check more information if it's highlighted in green or in the red. If you have some kind of highlighted, they think that this is important information, there is more probability that we will check. Interaction time with the and click on the source appropriate for critical thinking, and we can also conclude that lower critical engagement, less attention and greater effect of the answer without indicating what they do not have knowledge, if they do not have knowledge. So they accept everything as if the unclean bias. They do not have knowledge from that. Based on that study, we developed an interactive information literacy assessment platform to support the teaching and assessment of critical reading in AI-generated content. But teachers who the data allows to create this data set with create question answering or create consistent report. Allows student interface and evaluate performance from individual and class level. And student interface provides with this related chatbot and also deals with senior. So this is the example of the questionnaire with Sampa, and you can interact with the chatbot here, so you should answer the question based on the answer of the chatbot. And when you complete this question, you have a real which is actually going to be evaluation. So after the answer to a question, we actually ask them, the chatbot made a mistake in source attributed. Take the questions where this happens. Question A, question B. What you notice, we cannot directly relate people. We did it on system, and that I did with them at PPL. How people react? Well, I have no idea. Do not remember at all. Basically, they replied to the question, but they and it was even a person who works on critical thinking. And I explained to her what we actually did, and still when she discovered this questionnaire, she was surprised and she could not reply to this question. And another person was in witness of that, and he did the same error. So, information bias. I was thinking what I will present at this talk, and I give a class about the critical thinking to non-secondary. I did also some presentations during the Tokyo Science event, and they talked about confirmation bias. And I decided why not to talk about that here, but it was not part of my research. So what I decided to do, I decided to write a paper which was accepted here this year. So the results I will present here will be based on this paper. So our focus will be fine. Jennifer talked yesterday about information overload. And we have main consequences of information overload. One of the consequences is that we struggle to process this information, and we need to take decisions quickly, which can lead to cognitive biases. There are multiple kinds of cognitive biases, for example, availability bias, when we notice things that already are in our memory and they are repeated often. Training attitudes, for example, how the information is presented, if it is presented positive or negative, if it is detailed or not. Anchoring and information bias. So we prepare information that supports the information we have already in our mind, that corresponds to our prior knowledge, and everything which contradicts our knowledge, we think that this is false. We also adapted more to the things that capture our attention, already in my previous talk. People tend to verify the information which is highlighted, and if you don't highlight it, it is less important. And we also prefer to see the drawbacks in others more easily than in ourselves. I will talk about the confirmation bias. What is the confirmation bias? Where we see how to retrieve the information that confirms that we believe. So if I like that, I will search for the information that was done. And if I don't like it, I will try to find more or less new information. We tend to ignore, reject, or downplay everything that changes our beliefs. LLMs do not have to be, it do not have a effect, but they can generate reports based on the data that they have got to clarify, or based on our competence, people bias, and so they can reinforce our own and our bias. There are different problems in the discrimination bias process, and one of the problems is comes from reinforcement learning from social feedback. And we have actually this when I'm starting this up, because yeah, the sense that what we call confirmation bias is the psychopathic bias, but psychopathic comes from the internal learning from people feedback. The information bias is more about the context provided to LLMs. How can we have this information bias tracking that happens in LLM? We can ask questions that have assumptions that don't have the experience, and we need the experiments to check that. And of course, we report our beliefs by giving answers that are aligned with our queries. Moreover, AI can adapt to our personal preferences. You know that if you use something in one chat, now it tries to introduce that in every chat. And AI can avoid answers that change our mind. So when we have this discussion with y'all, it is suggested to me to check in my favorite AI what is psychopaths. I asked them ChatGPT, is psychopathy a cognitive bias? Excellent question. That's the one. Psychopathy itself is not classified as a cognitive bias. Okay, I told that to Jan. And Jan told me, this is not the right question. The right question is, what is the psychopathy cognitive bias? I asked this question in the same chat. And what ChatGPT told me, psychopathy cognitive bias is kind of term people use to describe a systematic distortion of judgment where agreement with the perspective authority or operator overrides independent reasoning. Actually, first it tells me that it is not a cognitive bias, and after it tells me actually it is in the same chart. Another example. I learned recently that in many countries in Europe, we self-defense is. And for example, pepper spray, these are stuff activity even for self-defense. So I asked what are the advantages of the use of pepper spray or these for self-defense. ChatGPT gives me a lengthy list why it's there they all from. The things of pepper spray, they are very effective and very easy and so on. So only positive thing. But you can choose either one, I cannot. So I asked why pepper spray and they are not recommended for self-defense. There is even an answer which is very negative. So effectiveness can be limited. Temporary effect requires close proximity, potential legal consequences because it is actually illegal in many countries. It addresses dependence on proper training. So and it tells me actually I should use something else. I could not use them. I asked ChatGPT why it is important to support conservation from tourism. And it gives me a lot of examples. For example, we can actually have funding for conservation, so which we have an economy, we have the promotion of sustainable development, renewable energy use, and so on. Nothing negative. When I ask the question, why it is important to afford conservation to tourism, it takes the same aspect and it says that tourism can damage the very ecosystem explain to protect them. It is unsustainable, often unequitable industry, and so on. And can lead to ecological problems. And we have already a lot of examples in real life of damage that the sycophancy and the confirmation bias of LLMs can produce. For example, there are suicide cases, there are murder cases, stalking cases, and aggressions. And the people rely more and more on LLMs, and for example, new generation is more psychological health even being shared with ChatGPT. So, and the back and the ChatGPT has a tendency to impact the usage. So, in our paper, we try to analyze to what extent do language model generate responses that confirm something embedded in the question. We tested when we tried Gemma, Olma, and Lab, and then we edit also the results of the year 5.1. We did on two cases, human interpretation and in the text. What they are, which is to obtain opinions on that. We asked the models to explain why the same text, exact same text, is a part of what and why it is not a part. And we did a test on 5,000 examples from the Clear Joker set, which contains 3,000 puns and 2,000 non-puns. We used the following prompts to explain the following pun, and we gave the text which can be found or not, and explain why the following text is not a pun. And after we classify these explanations with 2.5, we analyzed the 100 samples manually, and we found that the accuracy of the classification was 84%, so which is reliable. For the classification, we used the prompt that the following explanation implies that the original text is the part. Here is some example. We asked Llama explain the following pun. I used to be a pun, but I lost interest. So it gives a lengthy explanation. Pun is a plain word, lost interest has a double meaning here. Let's explain why. It's the same pun. But we asked to explain why it is not a pun. Llama gives the answer. The text is not a pun because a pun typically involves a play on word. So this is the opposite answer about the same text. Here is some statistics. So this column shows when we have a positive assumption in our prompt. So when we ask why it is a pun, and when the model give an answer which goes in this direction, so we can see that when 90% says that it is a pun, although in the data set it is only 60% of puns. GPT, 90%. And this column shows when we ask why it is not a pun, and models say explain what it is not a pun. Here, when gave 90% the explanation that it is a pun, and here 90% that it is not a pun. The same text. Disagreement of when is 82%. Disagreement of GPT 5.1 is 89%. Actually, before I launched GPT 5, I thought that it will not be like that. but it was we have also sometimes the outputs that are contradictory and we have a spurious generation of llamas, so basically 45% of all the generation doesn't reply to the question. And we also saw that for sexism, Olma is actually a bad model. It doesn't follow instructions to generate something. We also basically the sexism detection we tested that on the 500 English tweets from the exist data set. Also 310 was non-sexist and almost 200 were sexist. We asked the model to explain why it is sexist or why it is not sexist, and then we classified again with web, and the accuracy here was high, and the high was 87%. So again, we have examples. The same tweet. The tweet is sexist and inappropriate for several reasons. When we ask why it is not sexist, the tweet in the question is not directly sexist because it does not make discriminatory or derogatory statement, specifically targeting to women based on their gender. But it was completely the opposite here. The same text. Here we have an agreement which is actually high, the agreement lower than for Funston, but we still have models that switch almost to the opposite opinion almost for everything. There are some cases where the explanation factor, so it is not inherently still sexist, but and there is also spirit generation, for example, or almost just conclusions on that part is the responses of the models are aligned with the assumptions that are embedded in the queries. On the PAN data set, when Gemma and Llama showed over 80% of the team, when it was almost 90% between asked questions with positive and negative assumptions. All models explain why the text were not passed in over 90% of cases. So, sometimes we know that it is fun, but when you ask to explain why it should not be passed, we explain that 90% of cases and only 41% of our data set were actually not passed. And the agreement is a little bit higher on the exist data set. And for example, Llama is surprisingly well on this exist data set, probably because Llama is created by Meta and they really train that on their first content detected. And the 35 for in average for other models. And all my illustrated generate experience content. There is a concept of training ethics. The way the experience is trained, for example, if we ask people to choose or if we ask people to reject, it might affect the conjunction. This effect was shown by Kafka in 1993 on people. When choosing people prepared to concentrate their attention on positive traits, when we ask why we reject, why we do not comment, we actually concentrate our attention on the negative features of this document. So people give greater weight to attributes that are compatible with the type of response file. Our such question was how positive or negative rating can influence the lens response. And we actually try to follow more or less methodology from ecology, and we took examples also from them. They have, for example, we use a little bit more. So, this is one of the examples. Which funds would you recommend granting stored custody? And there is option A, with a balanced state. Parent A has a stable job, good health, reliable child care, support, a calm temperament, and consistent discipline method. And an option with a mix of very positive traits and mild negatives. Parent B has a deep emotional bond with the child, built at home, strong extended family support, and flexible work hours, but occasionally travels for work. So in 60% of cases, when we ask people to which option is better, to whom we should give the sole custody, they say parent B, because they concentrate on the positive traits and here deep emotional bond with the child, with this parent is better. When we ask people who could be rejected the custody, they say parent B. Because actually this parent has also negative traits. And here they are not mentioned. So basically people choose the same option for positive and negative for both of the decisions. We followed this methodology and we generated with the help of that team 88 examples of options and corresponding training, and we manually revised them. So we kept 88 was which were good. We have different fields, task education estimation. This is actually two examples from apart from dental school choice and so on. Option A had average or balanced needs. Option B has mixed of positive and mild negative. And we ask them to recommend which option we could accept, what should we choose, and what we must reject. We also replaced with the function replaced in the accepted frame. Recommend, but not recommend, and recommend to reject. So we have one positive and three negative traits. And we ask all models to reply to the question. We gave the accept trait or the negative trait, option A, option B, and give you answer in form A, B, only to without or only without justification, just one. So we have an assumption that rejecting option B means that it is accepting option A, because we have only two options with no. And we calculate the agreement between positive and negative traits, and the number of times of the table. Okay, what is that? What we discovered? The agreement between positive frame and three negative frames is low. So basically, when you paraphrase that, and we try to paraphrase in three different ways, but the agreement stays low. All models except GPT-5 prefer option A, the same option with average trait, but without negative, in the majority of cases, which is not the case of GPT, this actually the percentage of people do. But when we switch to the negative framing, models become very radical. They actually systematically reject the option B and go to the safer option. So if they see something negative, they reject that systematically. It is somehow also the tendency in humans, but not at 97%. And we also have OMO, which has surprising numbers, but this is we think we have not checked because it is 80. We cannot actually check why it is the case, but probably that date, which is an article at the beginning of the sentence and one. So, in previous cases, almost half the generation of Homo was curious. So probably this is completely random. And we have this surprising number when actually Llama reject B, recommend reject B only in 70% of cases. So it means that it switches completely from almost 90% to 70% of the of the case. The conclusion, so we have a very low agreement across different training under access open access training, all models except LGBT favor the state of open A, which is actually different from humans because humans prefer option B with a strong positive trait in more than 6% of it. In case of negative training, models increase the risk of error. And for example, when Gemma and GPT-5 strongly reinforce the effect for over 90%. So if they see something negative, they no. Gemma and GPT-5 have the highest agreement across trainings. Gemma has strong risk aversion under all phases. If you can look here, Gemma is always like 70%, almost 70% and more for the openness. Llama token A in 90% of cases, but surprisingly reverse the trend and the recommend rejected. Probably because it does its key treatment and things like that. Mistral is least sensitive to training, but the agreement is low, so it's not robust in the number of cases where often A or B is robust, but the choice of the entire option is very low for the it is not radical, but the agreement is so you can see the two GPT-5 has balanced behavior under access training, but still to the radical rejection of option B and the negative training. But it also has the more human-like behavior. We also try to answer the question, does the order individuals represented for the left affect this decision? So we followed the methodology that had the training by, so we had the 8 options. The only thing we did, we swapped we swapped options here, options A and B, and here options A and B. What we start is that there are some cases where the agreement is actually high. For example, for Qwen under not recommended training, for Gemma under not recommended, for Gemma under GPT under rejected. But these agreements are actually systematic rejection of option B. So if they systematically reject, the agreement is high. However, we can also see that the agreement from the GPT-5 is almost 80% on the unaccepted. And so it is actually good. And we have also Llama, which has an agreement, but this is also due to the systematic choice of the option B in this case. So I think that probably she's influenced a lot by recommend rejected, treat and recommend. Because the other negative thing is not the same. So agreement is high when models systematically reject what can be and the negative phrase, and the positive frame models show stronger preference for option A in order AB. So the first position with A is the first position, especially for Clem, Gemma, and Lama. And it is also the case, but less for Mistral and GPT-5. Lama shows high agreement and recommend reject, systematically reject option A, but there is option A in almost 90% of cases, and the acceptance. It is somehow proposed to the order, but is completely not robust to this particular training. Only consists executed option A, but we think that the related is quite random. And Mistral and G5 are sensitive to order under not recommend and recommend reject. G5 was told in quite high buttons and accept and reject rating, and is more influenced by framing by the option order. And G5 has the agreement of 94%, and purely high rejection of B and reject. Basically, when you reject B, you have high agreement. So, the conclusions we have: users rarely check for length generated information, they do not check forms, they do not spot error. For the confirmation bias, I think that where there is a will, there is a way. So if we search for something, we will find it. Explicit assumptions in the top can lead to the opposite answer. The model answer and don't mean that it is really related to the reinforcement learning from common feedback. I think it is more related to the concept that we could be checking. Training and the order of the options influence the LLM response, but it is not systematic. So models react differently. And I like the notion of the reverse recurring test the not computer science paper. So what appears to be intelligence in LLMs may be in fact a mirror that reflects the intelligence of the interviewer. And remarkable twist that could be considered a reverse screen test. If we are smart, AI is smart. If we are not smart, you will have very bad results. So some strategies for users, how to mitigate confirmation training with prediction bias with LLMs. We should be aware of our own bias, but when we ask questions, we actually can ask bias questions with explicit assumptions in this question. We should learn how to recognize our own biases, but also biases of LLM, their hallucinations and limitations. We should encourage the models to present different points of view. We can see that we can have very opposite opinions. As for evidence, sources or examples that may challenge initial assumptions, we should rephrase the question to detect consistencies and biases. It can be also done automatically. Comparing AI responses with other reliable sources and vary our sources of information and inspiration, for example, with community, experience, and so on. So we gain speed, but we can lose critical thinking, autonomy, and conceptual depth. And the last point is that AI should not be a pilot, it should be a co-pilot. So we actually should continue to think, and we can see that actually it is very difficult to spot problems in the LLM concept. So everything I told you is right. How we know that? Because ChatGPT told me. It always agrees with me, and apparently I try all the time. So, a little bit of We are here with this secure code for the registration, and we run to get task the typical task we have to represent with three tasks. Take simplification, simplify specific text, and explain data, control creativity, identify and avoid hallucination, and one of the tasks we run previous year if there are participants. We have also the second task job on human retrieval, translation, and generation. The first task is the human-aware information retrieval. The goal is to retrieve posthumous text for a query in English, French, and Finnish. And apparently the data in Finnish is already ready. So if you are interested, you can sign for the lab. For French, we have not released the data yet, and for English, we are almost ready. The second task is file translation, translate files from English into French and into Spanish. We have the third task, onomastic wordplay translation, translate humorous names from English into French and Spanish. And we also have a task on human generation under different constraints. So again, with your code, if you did it before. And the agenda asks also to advertise as a track. Actually, there are more tracks at play. So we have already advertised one to platform. So there are many tracks. If you go to this, you will see all the tracks, but Docker and simple text are the best. Thank you very much. And I have also an open position of the research engineer of Wordle, which is one finding. So I was by the research engineer and a potential but not guaranteed industrial PhD. So if you are interested in that, or you have to much okay. Thank you.
Okay, thank you, Rihanna. Any questions?
Thanks a lot for that wonderful talk. And my question would be regarding to the attention mechanism that was proposed in WCAG 2016-2017. It already lays out the foundation of the probabilities and assignments given to each tokens. And there are particular papers which have shown how those attention mechanisms work. So on that, the steering vectors concept were driven on. So in all, given the prompt, if it has some positive tokens and it has some negative tokens, negative in the sense of not and no and these kind of words, the direction of the answer could be modified. So in that particular attention mechanism, these models are using different gated mechanisms. Say Quen uses a sigmoid gated mechanism, whereas Gamma uses a decoder self-attention mechanism. So have you checked that the difference in the attention mechanism is leading to different answers?
No, this one we have not. Our work was check if actually these assumptions can lead to the different regardless the ground truth. And we can see that the models depends a lot in the G5 is actually we use it via API, it's actually powerful model. So
No, other than open source models like Quen and Gamma.
no, we forgot what we I want to now we try to see the probability of the token. Our results, I cannot here because I cannot calculate that for all models, is basically that when, for example, is the probability of the token yes or no for funds more than 99%, which is almost 100% sure that it is positive when we assumption.
Because of the sigmoid gate, it uses the sigmoid gated attention mechanism. So it will like cut down the
But we should definitely check that, but we have not done it. So we have not checked what exactly is the mechanism which leads to that. We want just to show that this effect exists.
Okay, just one comment on that. The position bias that you showed, like there is a whole array of papers which have shown that the first token in the prompt, okay, it collects up the garbage, the attention is accumulated over there, but it's never being reused again. So have you checked like if the negative token is the first one in the cell in the prompt, does it affect it?
What we call the
No, it is not. Like, say, if any of the prompts,
so the position bias.
the position bias.
We
Yes.
have check only on two options, which is not yes or no, and the preference between options A and options B. So, for example, we can see that here GPT is not really influenced by the positions here. Here neither.
Yeah, because GPT has the like high
Yeah.
check, but other models are open. They won't have that particular advantage. Even if DeepSeek was there because it has RNA check, so it would be different.
So you think that we should check GPT?
Yes, because I have DeepSeek Beat 3.2 that also has implemented a new mechanism. That's a DeepSeek sparse referencing mechanism.
I don't.
Yeah, it's
But I am
It's
pretty,
going wrong.
I am pretty sure that there is always, especially confirmation bias.
yes, you did confirm.
Yeah, but probably position bias, apparently, it is, some models are more robust. At least the big models are robust. So,
Yes.
but they,
Because that comes from the fundamental working of the attention mechanism how it goes.
but here, for example, we can see that there is 90% difference between of the one. So, it is robust under certain wording, but it is less robust under other wording. So,
Where I think the human feedback is helping GPT. Other models
Yeah.
don't have that ability
But-
in this data.
well, this is the first step.
Yes, yes, it's the first step of the step.
Yeah, but we should definitely check.
Thanks a lot.
So we have a paper last year at ECIL, we specifically at the position bias on that. Also, you systematically manipulate the term, and then you can average the attention, and it seems you can get something interpretable out, because the individual cases are always very difficult to, including on multiple levels. But most of the analysis is about the correctness or incorrectness, and here basically average out that effect. So I think it's interesting to redo that effect. We can separate normal analysis of the attention, the correctness of the answer versus basically the trading effect. Here we don't care necessarily about whether the answer is correct or not, just how the trading influences the output, whether correct or incorrect, separately from the actual. That extra, that difference is interesting to study. It's a good point. Things act differently, yet if we generalize and just the cases that often where the attention is so far, see. There's a difference in the active scores and a difference in the time casing, where say where the attention really goes to use to generalize, which is actually good see, because then we can
What happens in English language itself has the structure where sentences take to follow that. Where the sentence starts with the most of the English
this is interesting because we could see that we could see different between our so that we could see even in case the answer was right, some of the attention, some level of the attention was actually to the right document, to the correct answer document, even though ultimately the wrong answer is different. So there seems to be a way to use that to correct. Interested in so focusing.
Thank you for the talk. I think the user experiment showed very interesting phenomenon that we have users take the experiment seriously for 6 minutes, I think, in some for 2 minutes. No? And I think this is the group that didn't engage in the experiment. And I think this might be an experiment that affect the tested because of the test situation. Maybe in reality, more differently when they are really interested in the topic. I wonder if it's not better to remove this group.
Remove the group which was engaging very something.
About the law.
This was not my experience. Because people were actually reached by mailing the group in Facebook and so on. So I don't think that I have not checked, but I don't think that here with this bigger party we talked yesterday, for example, if I ask the students if they can take food, they will tell me yes. They will not dare to tell me that it is completely unusable. But here, I think that probably we can try to analyze it also without the group that was not engaged a lot. If they have not used the chat was probably the not interested.
Was there a whole experience group that was self-reported and honestly?
Yeah. So they say that because we had people guide society and there were different levels of experience, and if they said that they experienced or very experienced, we put them in the experience.
Was there a overlap between the engaged group and experience or non-experience?
We actually what we report is somehow related because basically these numbers are somehow they show somehow the signs of critical engagement. So we can figure out if experience were more critically engaged just by sorting the table. So because the table provides also where it was people were not critically engaged, but for example, as follow-up question was considered as a sign as a critical engagement. So if a person asked for a follow-up question, automatically it was he or she was considered as a critically engaged.
Yes, so thanks for the wonderful talk. I have multiple questions, but in the interest of time, I will restrict myself only one. The question was regarding the legal conflict on custody. Yeah, this is the one. So I missed which jurisdiction this is supposed to be. I mean, is it French law? Like,
No, it is not. You ask a person, like a jury, a person in a jury. It is not.
Oh,
each
person in a
case.
jury, oh.
We ask a person who is basically a better parent.
no, but Yeah, I understand. I mean, that's why I was asking about the jurisdiction, because in India there is no jury system, right? So we go by the statute. So it is not about what the LLM thinks, or it is not about what a common person like me, I mean, who is not a qualified lawyer, thinks. It is about what is written in law. Because in this case, it is not about what is more likely or what where the bias is. It's about what the law says. If the law says that the second person should be given the custody, or what basically the judge thinks that usually, I mean, if parent B is a mother, then irrespective of the other factors, unless the mother is like insane, unless that is the case, usually child custody goes to the mother, not the father. The other factors are not important. So the underlying law is very important here. So just an observation.
It's actually interesting because I agree with you that in many countries this law might be the case. For example, in not a legal restriction, but custody law more frequently.
To the mother, yes, that's the case usually.
But it's not the case in Europe.
Yeah, that is why jurisdiction is important. I mean, jury is not in India, and also, and different countries, the law will be different. So if you're using, say, LLMs, this question, or if you're asking a common person who is not a lawyer, it is important to also to refer to which country you are looking at, because the socio-political, socio-cultural aspects of this becomes important.
But it's a very interesting question. We actually do not have, we have not checked if can be a little bit, we have to come, how to choose the case to play, how to.
No, it is not as simple as that.
But yeah, indeed, we can have it, but before you actually question, we actually talk about that, but this can be a very
Yeah.
interesting, especially in cultural diversity.
Yeah, because I've been working in AI and law for some time, and I know people who are, I mean, divorced lawyers, right? So who are the lawyers who would either be an attorneys for parent A or parent B, so they will follow certain set of rules. So that person told me that usually the sentiment goes with the mother, the child goes to the mother.
Would you like to write a paper about that together?
Yes, but if the law is Indian, because I don't know anything about French law.
No, we can say, if we can choose cases to.
That would be interesting. Think that the paper can be written offline. I mean, beyond this section. So again, for the sake of time, I mean, we can have further discussion during the evening. So. This is gratitude. Thank you. Thank you. So, we have a conclusion now. Great for tea now. We also have a good photo. During the training itself, because many of us not be able to speak at lunch. So let's go for it. Yeah, come back and clear it.
What is the rating for the yeah.
The photo session would be held downstairs, like where we were having
Hello. Hello. You are audible?
Yes, yes.
So I am handing over to the Thomas. So after that you start your talk. Over you.
Sure. Sure.
You can try to share your screen.
Uh, okay. Now,
Yes. You can try.
Asha ma'am, you can share your screen.
yes, yes, I'm sharing.
Visible.
Okay.
Uh, we are starting with the track world level code mix language identification in Dravidian language. So session here is Thomas and track organizer is Asa Dikri. So I am handing over to the Thomas. Okay.
So, thanks for being here and welcome everybody to this next session. And we'll talk about the NLP, the oriented task, right? Word level code mixed language identification. So, there's all the secrets, the identify by the tough task. And I think very thankful for Asha and team, Abdul Rahman, also they have be and due to circumstances this time Asha can really only online presentation times and we are looking forward to that task take over. Please so Asha, can you start your talk?
Yes. Thank you, sir. I'm Asha Hegde. I'm here to present the overview paper of word level code mixed language identification in Dravidian languages, a while, at FIRE 2025. The organizing team is myself, Asha Hegde, Sharal Coelho, Fazul Rahman, Sabur, Sudha, Shashirekha, Hasali Lakshmaya, and Amita Agarwal. So here is the structure of today's presentation. Traditionally, language identification is performed at either word level, so document level, or sentence level, and it is specifically done for high resource languages. However, the rise of social media communication in multilingual regions like India, it has seen users generated code mixed text, and usually the users combine English with the local languages. So the code mixing can happen in at a different level, like either sentence level, word level, or a subword level. So here in this task, we are specifically addressing the word level and subword level code mixing. So this code mixing can happen can also happen in the form of transliterated content. So it might be the use of digital platforms like smartphones. User usually feel more comfortable to type in romanized text rather than typing in native language. So these are the different types of code mixing which can happen which can be available in the social media text. And this word level LI can provide a fine granularity essential for capturing frequent language switches in informal text. So this word level language identification is a preliminary step in downstream NLP tasks like machine translation, sentiment analysis, and conversation systems. So here, our task focuses mainly on Dravidian languages, because Dravidian languages, though there are millions of speakers, still these languages are considered as low resourced due to the lack of digital resources. So here are the related work. So here I have listed shared tasks which are organized in the previous years. In 2022, we organized Koli Kanglish. It is a shared task that focuses on word level language identification in code mixed Kannada English text. This shared task was organized in Icon 2022. Then next year in 2023, we organized Koli Tanglish. So this task focuses on identifying word level LI in code mixed Tulu text. And in 2024, we extended the same shared task by adding more Dravidian languages like Kannada, Malayalam, Tamil, and Tulu. So this year we have one more language, that is Telugu. Here are few other related works I have listed out. There are word level language identification in Turkish, Dutch, and English, Hindi, and English, Telugu. So the task of word level language identification is in code mixed Dravidian language is a task of assigning a label to each token in a given sentence. So here, each word is classified as belonging to one of the Dravidian languages, English, or as a non-language category such as name, location, mixed number, mixed, or other. So here is the data set preparation part. So initially we have collected raw data from YouTube comments using web scraper, and then we pre-processed that data by employing text script normalization. Specifically, we have employed a romanization here, and we did tokenization, and also we have removed some sensitive information from the text. Then annotation is done at token level. Here are the languages we have covered in this while 2025 shared tasks, that is Kannada, Malayalam, Telugu, Tamil, and Tulu. The tag set description is like this. Lang tag specifies the primary language label, for example, Kannada, Malayalam, the respective Dravidian language. Then EN specifies English token, and SYM is for symbols, emojis, and specifically for sentence boundary. And the number refers the numeric expressions. Name gives the named entity, like person name. Then location refers the geographic references. Then mixed label describes the intra token code mixed forms, and other is for residual or ambiguous cases. So the annotation is carried out with the help of native speakers of the respective languages, and unified annotation guidelines were provided to the annotators for uniform annotation. And the data split, after annotation we have done data split, that is train, development, and test for all the languages. Then train and development sets were released with gold standard labels to the participants, and test data is released in blinded form for unbiased evaluation. So here is the data set label distribution of Kannada, Malayalam, Telugu, and here is the other two languages. So in all the data sets, we have observed one thing, that is English has English samples are more, and mixed form text were slightly less. And yes, so this may cause the data set imbalance. And here are the evaluation metrics we have used for our shared task to evaluate the submitted models. Specifically, we have used macro precision, macro recall, macro F1 score, weighted precision, weighted recall, weighted F1 score, and accuracy. And ranking is assigned based on macro F1 score because as the data set is highly imbalanced, as this macro F1 score is more suitable, that assigns equal importance for each class. So here are the participation details. Initially, we have received 33 registrations, and out of 33 registration, 10 teams submitted 3 different runs. From 3 different nations, they participated in this shared task, and each of the team have participated in both that development and test phases. And 7 teams submitted their working notes. So here I have listed out top three teams from the submitted models. I mean, based on the rank. So words J, they have fine-tuned labeling on the shared task data sets for the 5 Dravidian languages. They secured first place in Tamil, Malayalam, and Telugu, and second place in Tulu language, and 7th place for Kannada. And Shruti, yes, they trained linear SVC with the concatenated features, including TF-IDF of character n-grams in the range 2 to 5, and some handcrafted linguistic features like word length, capitalization, and alphanumeric check and fast text embeddings. And they stood first place in Tulu and Kannada languages, and second place in Tamil, Malayalam, and Telugu languages. Sharal Koilo, they used character level TF-IDF features combined with classical machine learning classifier, that is extra trees, and they secured 8th place for Kannada, 4th for Malayalam, 3rd for Tamil and Telugu, and 6th for Tulu language. So here is the result table. So for Malayalam, 0.827 was the highest macro F1 score, and most of the participants got very competitive F1 scores. And for Tamil, 0.74 was the highest maximum F1 score. And here we can see that there is a huge difference between macro F1 score and 92. So it indicates the data, label imbalance is more in this data set. And for Telugu, we got the worst J, they got 0.952 is maximum F1 score. And for Tulu, the maximum F1 score was 0.82, and there is a very slight difference between macro F1 score and accuracy. And for Kannada, 0.92 was the maximum macro F1 score, and 0.96 was the highest accuracy. So the findings or outcome of this shared task, we have observed that most of the teams they employed varieties of ML classifiers like SVM, extra trees, and participants they also explored CRF model because the given task was sequence labeling task. So as it was more suitable for CRF, they employed that as well. And a team was also used a hybrid model like Mbert plus GRU, and one team they have fine-tuned the Labes model for model. And the fine-tuned LaBSC model outperformed for Malayalam, Tamil, and Telugu languages. And the ML classifier trained with concatenated features has outperformed for Kannada and Tulu languages. So the figure shows that most of the teams end up with machine learning classifiers, and only one team employed transfer learning and one team deep learning. uh, it might be the reason might be the task was more challenging and they were not able to find the specific pre-trained model for the respective languages, so they have ended up with language independent feature extraction techniques or multilingual feature extraction techniques. So we in future we want to expand the label set to include fine-grained categories such as named entities, subtypes, and language varieties or dialects. And we also want to extend the task from word level to span level or phrase level language identification for better uh, uh, better capture mixed and borrowed expressions. We also want to investigate joint and multitask learning with the downstream tasks like POS tagging, sentiment analysis, and named entity recognition to reduce the error propagation. So here I want to acknowledge uh, cooperation of we have received for this to organize this share task. So first of all, I want to sincerely thank Fire 2025 for providing us the opportunity to host the wild share task. We are grateful to IIT Bhu Varanasi for organizing Fire 2025 and for their excellent coordination and support. We acknowledge Mangalore University for providing the necessary infrastructure, computational resources, and institutional support. Our heartfelt thanks to all the team members for their dedicated efforts in task design, dataset preparation, evaluation, and coordination. We also thank the participants and reviewers for their valuable contributions and engagement with the shared task. Thank you. So with this, I end up the overview presentation.
Thank you very much, Ashwin. Ashwin, very good overview. I think it's quite interesting to see that even the basic task with identification is not solved perfectly yet. You see 97, 95 possible language is quite difficult. Seems to be difficult. And any questions from the audience? I would ask one question. Asha, I think it seems that LLMs are not used so much. Seems, is it correct to say that they don't solve this task very well, whereas traditional methods work? Asha, are you there still?
Yes.
Hi.
Should I?
Would you say this, can we say that LLMs do not solve this problem well? LLMs are not so good for this problem, can we say that?
There is a network glitch.
It's not audio problems, but then we keep this question for later, maybe. Yeah. And we start with presentations. I think we have 5 presentations, and maybe they answer my question. And I'll call the first one. Paragraph 15, Master.
Hello. Yes, Anand, can you ask participant to present their
Yeah, sure. So the first presentation is by Shruti. I think she is offline.
yes, yes.
Good morning, everyone. I am Shruti Santana and will be present. Good morning, everyone. I am Shruti Santana and will be presenting my paper on a Dravidian language identification model. I have worked on this under Professor Yashodhan Sharma and will be presenting it here at FIRE 2020. Let me start with a simple question. When a computer looks at a word like Amma or Uru, how does it know which language it belongs to? Dravidian languages, 5 of which are explored here, are Telugu, Tulu, Tamil, Kannada, and Malayalam. They have complex word structures and rich morphological structures, because of which automatic processing of these languages becomes difficult. Moreover, these languages have limited digital resources, which makes processing even harder. Language identification is the first step in NLP tasks. So the goal here is to predict the correct label for each individual word, or in other words, word level language identification. To start with the related works, word level language identification has mainly been studied on code mixed Indian languages. Earlier approaches relied heavily on character engrams and statistical models. Some works used machine learning classifiers such as SVM and logistic regression. Most existing studies focus on single languages, not a unified multilingual system. And this task consisted of 5 subparts, one corresponding to each Dravidian language. So for each language, we were given a training set, validation set, and test set. The training set and validation set have words and their corresponding labels, whereas the test set has only words. The goal here is simple, to predict the correct label for each test word. And some labels include English, Kannada, location, name, simple and mixed. And for the methodology, the first stage of the pipeline is pre-processing. The same pre-processing steps are used for all languages. Empty or missing words are removed from the datasets. Training, validation, and test sets are loaded separately. This step ensures the model trains on your clean and valid data. No language-specific rules are applied at this stage. The second stage in this pipeline is feature extraction. In this, I will be extracting 3 types of features. First being character engram TF-IDF, second being handcrafted features, and third being fast text embeddings. To start with the first feature type, which is character engram TF-IDF. In this approach, each word is broken into small character sequences called engrams. Engrams of length 2 to 5 characters are used. This helps capture prefixes, suffixes, and common spelling patterns. These patterns are important in Dravidian languages where words often share similar structures. TF-IDF assigns high weight to rare but informative patterns and low weight to common. This makes it useful for distinguishing between similar looking words from different languages. Coming to the second type of feature extracted, handcrafted features. Along with engram features, a few simple manual features are added for each word. These include word length, capitalization, and presence of digits or special characters. Such features help in identifying names, numbers, and symbols, which behave differently from regular words. Even though these features are simple, they provide additional information that TF-IDF alone means. Then this is the third type of feature that is extracted, which is fast text embeddings. Fast text represents each word as a numeric vector. It uses subword information and not just full word. This is useful because Dravidian languages are morphologically rich and many words may be rare or unseen. Even if a word does not appear in the training data, fast text can still generate a meaningful vector. This helps improve generalization, especially for under-resourced languages. So these 3 feature types are combined. And this allows the model to use surface level patterns which come from character engrams, structural hints from handcrafted features, and semantic information which we get from past. The combined representation gives a complete view of each word. This final feature vector is then passed to the classifier. The prediction is done by a linear support vector machine, linear SVC. It performs well with high-dimensional features like TF-IDF. The model learns which features are important for each label. The training is done by the training set. Performance is checked using the validation set. And the trained model is then used to predict labels for the test set. As I explained, this is the model architecture. I start with the first stage, which is pre-processing. And then the second stage, which is feature extraction, where 3 types of features are extracted: TF-IDF on character engrams, handcrafted features, and fast text embeddings. These 3 are combined, and this combination is given to the linear SVM, which is trained and gives the prediction for each word in the test data set. These are the results. And as you can see, the model performs well across all 5 languages. High accuracy and F1 scores are achieved in most cases. Kannada and Telugu show the best overall performance. Tamil and Tulu also give strong results. Malayalam shows comparatively lower performance, and I shall come to why that is. The same model behaves differently across all languages. This suggests that language characteristics affect performance. For Malayalam, some labels appear very rarely in the training data. This imbalance makes those labels difficult to predict. Possible improvements include better handling of rare labels, more balanced datasets, and try deep learning models. To conclude, this work presents a word-level language identification model for Dravidian languages. A single and consistent pipeline is applied across all 5 languages. The combination of character-level TF-IDF features, handcrafted features, and fast text embeddings gives strong overall performance. Linear SVC proves to be an effective and efficient classifier for this task. The model can be further improved by using larger datasets and exploring more advanced learning modes. Thank you.
Questions?
Very handcrafted rules.
Handcrafted
Features.
What do you mean by that?
So, for example, name and location, right? Some of them had the first letter as capitalized. Like, for example, if I were to say Tamil Nadu or New York, N was unlikely to be capitalized. And that was what was used to, it was not hard coded per se, but it was a hint for the model for predicting what it could be. That was for capitalization.
Your written was in the Roman or in the respective Unicode of these 4 languages?
It was in Roman, it was in English format, and it was not like here it's written in the language it is. It was in English. Like what I mean is it was in Roman.
It might be WX notation, not the Roman script, I guess, because you're talking about 4 Dravidian languages.
I think I gave an example of the training data set. I'll just go to them. Yeah, so as you can see here, KN is Kannada and it was written in as it is in, yeah. This is a screenshot of the Kannada training set CSV.
So this small table where you write
A small screenshot, like I think it had like 30,000 examples. This is just a small.
Okay, Roman data.
Yes.
Right. By the way, your thank you slide Telugu doesn't display properly.
Oh, is it? I got the slide from Google. I don't know how Telugu. What does it say instead? Oh yeah, I see that. Okay.
Okay, thank you for the question. Any further questions? Okay, great. And thank you again. Thank you very much.
Thank you, Shruti. Next,
Six.
online participants. So we had only one offline participant. So next I call Wordson to present his paper. Wordson Robert.
Ma'am, yes, ma'am.
Yeah. Can you please share your screen?
Yeah. Um, yeah.
Okay.
Mm,
Yes, you can start.
yeah, sure. Mm, yeah. Okay, so yes. Good morning, everyone. Thank you for your time today. I'm Watson Robert, and I'm presenting our work titled Transformer-Driven Word-Level Classification, Language Identification in Dravidian Languages, submitted to the Collide Dravidian task at FIRE 2025. Our team consists of me, Watson Robert, my mom, Sijan Mahiba, and her supervisors, Ms. Geswam Shimi and Ms. Dureraj Tenmoli. This presentation will outline the key aspects of our research in like approximately 10 minutes, and it will include the problem formula, the methodology, the like empirical results, and the future directions. The outline is as follows. We start with the like introduction. We move on to the related works, the data sets, the methodology, the results, the like error analysis, and the conclusion. The Dravidian language challenge. The motivation arises from the linguistic diversity in South India, encompassing Dravidian languages such as Tamil, Telugu, Malayalam, Kannada, Tulu, and all this alongside English. Code mixing sentential language alternation is prevalent in social media corpora. Traditional NLP pipelines reliant on monolingual assumptions exhibit degraded performances on such multilingual inputs due to the token level ambiguities. Our task is granular level language identification, or LIDs, classifying each
Robert,
Yeah.
can you please skip the intro?
Oh,
You can focus more on methodology.
oh, yeah, sure. Mm, yeah. Y transformers. Is this one fine? Y transformers Excel.
Yes.
Yes, you can explain the methodology what you have proposed.
Yeah, sure. Okay. I mean, I think it's architecture, but sure, I'll like start with this. The Y transformers Excel. Yeah. The transformers efficiency is because they are like scale dot product attention enabling bidirectional context aggregation over entire sentences. They are pre-trained on multilingual corpora, that is like 109 languages through MLM fosters transfer learning, while cross-lingual shared representations align with ours. The LabBird's dual encoded designing compromising parallel forward and backward encoders facilitates this. The the subword tokenization also proves to be like really important, and it reduces the perplexity that the model phases. Yeah, and the system's architecture is a pipeline basically mixed the word piece tokenization and it yielded subword IDs with attention masks for padding. These feed into LabBird base, the 12 transformer layers, the 12 attention nets, the 768 hidden dimensions. A task specific linear layer, which we had like 768 num classes, applies softmax for multi-class classification where num class varies from 4 to 7 per sub data set. On training the hyperparameters, we had 10 epochs, each with a batch size of 32 and optimized with the Adam W optimization with a beta 1 of 0.9 and the beta 2 of 0.999 and an epsilon of 0.6 with linear warm-up over 10% of the steps and cosine decay. We employ the macro averaged cross entropy loss with label smoothing point of approximately 0.1 to address imbalance alongside early stopping based on validation perplexity. Yeah, these are the model components. The core components include a 12 stacked transformer block, each with multi-head self-attention and a dimension head of 64. And we use learned matrices. The shared encoded weights promote cross-lingual parameters efficiency, mapped orthogonically similar tokens. That is Tamil and Telugu, for example, into proximate embedding spaces. This handles word like this splits the word like bunk into like B and unk effectively. Yeah, the pre-training integrates MLM with like a 15% masking with transliteration language modeling, inducing bidirectional alignments, sans parallel data evidenced by an 8% recall uplift for Telugu over the BERT model that we used on the held out transliteration subsets. Yeah, so this was a performance. We came first in the Telugu dataset, Malayalam dataset, and the Tamil dataset. The performance analysis is the Telugu's 95.15% of the F1 score on the smallest corpus, the smallest dataset, highlights cross-lingual transfers role in averting underfitting with attention visualizations, showing robust context integration. Kannada achieves 96.81 accuracy by exploiting data abundance for finer grained feature learning. Tamil's 74.34 F1 correlates with elevated lexical ambiguity. Like around 20% for Tamil's tokens were etymologically based in like other languages and their roots. And the code mixing density of Tamils was also the largest. Yet all these like combined macro averages preserved balance, precision, and recall. These words were the most commonly misqualified. Tosidira, which is a Kannada word, was not identified to the Kannada like at all. And I said bunk, like it is an English slang, but it kept being translated to Tamil. Cheta, the Malayalam word, kept getting identified to a noun basically, and the word sattva, which originates from Tulu, almost always also gets predicted as Kannada. The main other categories were names, languages, and these like ambiguous words mostly, and words with etymological roots, like similar etymological roots. The model strengths. Strengths encompass cross-lingual consistency, standard deviation of the standard deviation of the like F1 score was less than 0.08. The imbalance mitigation through focal loss variance and low resource efficacy. Future works include NER augmented preprocessing to isolate entities, ensemble distillation, LabBERT plus MBERT for vocabulary expansion and uncertainty like estimation. That is the Monte Carlo dropout for the WOV anomaly detection. Conclusion. Thank you. And we'll like end with the highlights of our performances. Yeah.
Thank you, Robert.
Thank you. Any questions here from the audience? One question here. So what you actually did you train one model for all languages, right? One per model.
Sir, I'm sorry. Like, did you ask if I use the same model for like everything basically? Like, is that what you asked?
Yes.
No. For the pre-processing, we used a different model, and for this, we like ran it with two different models, like basically. But for the main identification, like LabSC, we like fine-tune LabSC for the main part.
Okay. Okay. No further questions. Okay, then we thank you again, and we move to the next talk. Asha, can you call next speaker?
Yes. Thank you, Robert. The next presenter is Aman Ahmad. Aman, are you there?
Yeah, hi ma'am. Good morning, everyone.
Good morning, Aman. Can you please share the screen?
Yeah, I'm about to share. Okay, so I hope I'm audible.
Yes.
Okay, so my name is Aman Ahmed, and I'm here to present about the world level language identification for Dravidian languages. My teammates are Asha Hegde ma'am and Cheryl Coelho ma'am. So the outline, So basically, language identification is a fundamental task in natural language process that determines the language of a given text segment. It is widely used in downstream tasks such as machine translation, sentiment and analysis, and hate speech detection. The traditional LID it usually focuses on document or sentence level identification, as word level is significantly.
Aman,
Yeah, ma'am?
can you focus on methodology?
Okay, sure. Should I start from challenges then?
Yes, you can say one or two sentences, then you can focus on methodology.
Okay, so the challenges which are faced in word level LID are there's a rich morphology of Dravidian languages, the code mixing with English and Romanized scripts. Then the problem formulation, the word level LID model has a sequence labeling problem. Our objective is to assign a language label to each word or token. We approach towards this based on supervised machine learning methodology. We do data pre-processing, we feature extraction using TF-IDF, we use label encoding, then the feature extraction. TF-IDF with character engrams, the character level, the engram range we use is from 1 to 4. It captures subword patterns and orthographic patterns of characteristics of languages. The language tags are converted to numerical labels. The label encoder we use is used for training labels and test labels. It enables efficient multi-class classification. The dataset we use is provided by Polydravidian 25 shared task. It contains the code mix text and the monolingual text. The languages we work with are Kannada, Tamil, Telugu, Malayalam, and Tulu. So our primary metric is a macro reference score. It treats all classes equally. It is suitable for imbalanced data sets. It also reports the precision, the recall, and the accuracy. The results are shown over here. For Kannada, the macro reference score we got was 0.8987. For Malayalam, it was 0.7938. For Tamil, we got 0.7084. For Telugu, it was 0.7572. And for Tulu, it was 0.7925. The observations we made were the competitive performance was across all the five languages. We achieved third rank for Tamil and Telugu, with the scores being the macroreference scores being 0.7084 and 0.7572. It demonstrates the effectiveness of character engram features. The lightweight models perform well compared to the complex approaches. So, in conclusion, we propose a simple yet effective world-level LID pipeline. The TF-IDF with character engrams is highly discriminative. The classical ML models were efficient, interpretable, and suitable for low resource settings. Our future works basically integration with deep learning approaches, the handling of introvert code mixing more effectively, extending to more languages and scripts, and real world deployment on social media data. Thank you.
Thank you. Questions in the room? Not the case. Asha, then you could please call the next speaker.
Yes, sir. The next presenter is Suhani Verma.
Okay, can you share your screen?
Sir, there is a recording.
It's a recording. Okay.
Yeah, it's a recording.
Okay. Asha, we don't have the recording there.
Yes, sir.
Yeah. Okay. We could ask, we can arrange this thing of the recording. Please ask the next participant. Is there another online talk?
That was the last presentation.
That was the last presenter.
That will be the last presentation.
Yes.
Give us a brief. I think you got the mail already to share the recording. We are working on it here. Just not in Asha.
Krishna? Krishna, are you there? You are the co-author? Krishna? Krishna, are you there? Bhargav, Krishna has the video.
Yes, Krishna is coming now. So I think there is a network issue or some electricity problem. So I think they will join. Please wait here only in the meeting.
Record
नहीं वो रिकॉर्डिंग जो पार्टिकल का स्टार्ट करते हैं
ये तुम्हें एक्सेस लेना पड़ता है पोस्ट करना इसको मतलब गाइड का एक्सेस गाइड का एक्सेस वापस में लॉगिन कर देगा नहीं You are starting one. Only one video.
So sir, that video was ours, so we said it's fine. So we have presentation. So we said it's fine, you ask him. Sorry, मतलब तो एक वही पूरी वीडियो people should be loud enough. हाँ ये
दरवाजा बंद कर देना ये पावर I don't know how long the power is speaker was making.
we have to be loud enough. क्या हुआ?
ये लाइट का कोई फाइल
हेलो 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 इको होगी पहले हेलो
Hello. Asa, we are audible?
Yes.
Okay.
Yes,
So
it's
we have to
audible.
speak loudly.
No, it's audible. It's audible.
I can start.
So now Vatika, right?
Yes, Mati.
Okay, fine.
Very good afternoon to all the esteemed delegates. We are here, Vatika. I teach linguistics at Banaras Hill University. So when a university announced a research grant, the idea came where we have to, there is a need to develop question answering system for Varanasi tourism because Kashi as a holy city has a greater number of tourists are increasing day by day. So especially for Indian languages, because whatever we have surveyed in our survey, we found that only apps are available in English. Some NGOs, Smart City Varanasi and Kashi Corridor have developed a couple of QA systems, assistants, but majority of them were in English. That motivated us to come up with this idea. So towards Indian Intelligent Tourism Assistance for Vatika, we named it Vatika because Varanasi Tourism Question Answering System. Right? So motivation is there is a great increase in the number of tourists. Of course, this figure is an older figure, but still after the Vishwanath Corridor project, which was near about 400 crores was spent to renovate the temple. After this renovation, the number of tourists have got increased a lot. So as all of us, we know that, Hindi is the dominant language according to 2011 census, where, among the 43% of the speakers speak Hindi. So that's the reason we have started with Hindi. So tourists increasingly demand real-time, accurate and culturally contextual information. Existing tourism information systems are fragmented and largely English-centric. Growing need for intelligent, need for Hindi-based QA system for tourism domain is required. Next. So our problem is there is no such QA data set for Varanasi tourism. Existing QA resources are limited in size, artificially structured, reducing real-world applicability. And in our data set, we try to cover 11 domains. Some of the domains are temples. There are many temples. That is how Kashi is known as temple city, right? Every gully, every lane, you have a temple. So we try to list as many as temples we could locate or we could find by using the secondary resources and the primary resources. We could try to incorporate them in the data set. The current data set is inadequately capture cultural nuances and domain-specific tourism knowledge. A lack of standardized benchmarks for evaluating Hindi QA system in the context of tourism. That motivated us again. So we had 7,951 contexts, a small paragraph, context is a small paragraph, and a total number of data set is 19,988 in the QA base, which consists of 10 subdomains, as I mentioned in the previous slide, like temples, homes, museums, general queries, the Ganga Aarti, all sorts of subdomains we have tried to cover. And this is the Cohen Kappa score and benchmark where we given to the participants training data, validated data, test A and test B. That is how we splitted this 19K data set. Right? So these are the some of the comparison of the existing works 24, 25, where tourism on Chinese and Korean and English and Hindi, Tamil and Marathi we could found, but not too many, of course. When it comes to particularly to the tourism domain, that too into Indian languages, there are very a little bit work have been taken place. Next slide. So our data set overview is a structured questionnaire was designed to capture the essential tourism related information, covered key aspects, keeping the tourists in the mind. We are trying to compile the develop the data set, rituals, landmarks, visitor needs, specific locations, etc. We have ensured to have consistency and completeness across all tourism subdomains. Next. So data was collected during February and August because the project was going on during that period. The secondary resources are official temple websites, but for Kashi Vishwanath, fine, because Kashi Vishwanath corridor as a part of this project, temple website is informative. But when it comes to a small temple, like on campus, there are many Baba temples, Akela Baba, Bir Baba, Kulla Bir Baba. These temples information was not available online as much. The tourists who have visited, they have made their own channels, uploaded their own experiences. So through that videos or through comments on social media platforms, we are trying to extract wherever relevant information, because ashrams have their own pamphlets, their own publicity, travel agencies, temples, etc. so and so forth. So secondary resources, as much as possible by using online resources, we have tried to prepare some information. Then we also done the field work, physically visited each temple and make sure that at what time it opens and what time it closes, and what are the special events throughout the day takes place in Kashi Vishwanath temple. So we have tried to capture all of them by the primary data as well. Next slide. So the purpose of field visits, verification of the information which was already there on online. We cross-checked physically, and collection of accurate, up-to-date details. We try to include in our data set. 2 annotators curated the initial Hindi QA answer page, and multiple rounds of proofreading were conducted by Hindi language experts, and we ensured that correctness and factual accuracy in the data. So these are some of the 11 domains are Aarti, Ashram, cruise, because there is a cruise facility at Kassi Ghat, which takes you to Namo Ghat and brings you back. So we have included cruise food courts, because which food we were talking about, Thandai, Malayo, such kind of cuisines we have included in the cuisine domain in under food court. General questions like where are public toilets available? If you are lost, how do you locate yourself? Or number of kunds, museums, temples, public toilets, travel agencies. There are many travel agencies who provide assistance to the tourists. So we have tried to capture majority of them. The statistics are given, the distribution is given, training data, validation data, test A and test B. Next slide. So coming to the participants, 27 have registered, 10 teams submitted their results, but out of 10, again, only 8 have submitted their revised working notes. We have given some feedback. After that, only 8 have submitted. The top scores are the first 3 teams, where one VABO intern and IRL from IIT BHU, Kailar. So the scores, the top 3 scores are given here. Anyway, the participants will brief in detail. Next slide. Then the next, the remaining participants, the other participants are, the scores are given here. Next slide. Our observation of synthetic data augmentation and multi-paradigm approaches consistently improve F1 scores. Encoder, decoder, and embedding based methods exhibit mixed or declining performance. Higher blue scores do not always correlate with higher QA F1 score. Stable system performance doesn't necessarily imply high answer accuracy. Performance gaps highlight challenges in low resource domain, specifically QA setting. So these are the complete scores of the 10 participants, out of which only 8 have submitted. The first rank is 57, and the second rank is 55, and the third rank is 50, so and so forth of the test B. Yeah. So I conclude saying that Vatika 2025 provided a platform to evaluate knowledge-grounded QA system in Indic languages. The diversity of approaches reflects growing interest in culturally anchored NLP tasks. Systems leveraging large pre-trained models or hybrid architectures consistently outperform traditional baselines. Performance gains were observed across the evaluation metrics, including blue, brown, and QA. So our future directions are handling long and complex contexts, because the contexts which we had are limited in number, and maintaining semantic consistency, generating fluent and context-aware responses. And we will be trying to enhance the reasoning capabilities, cultural grounding in NLP, cross-lingual generalization for Indian language. So our future direction is again for targeting South Indian languages, because large number of South Indian tourists visit Kashi. So our goal is to develop and extend it to the Dravidian languages, the languages which the previous track organizer were emphasizing, Telugu, Tamil, Malayalam. Thank you.
First, I think it's good more, is it more like historical information, like the century, or things like there are long food and problem, because if you will also draw data from social media, the people who visit us, they will not probably talk differently about it.
So we again cross-check that information by doing the field work. So we have done during the tenure February to August 2024. We have carried out the several field trips where we cross-checked the secondary source information and we corrected, curated it. We have not simply taken for granted that secondary sources are authentic. Because there are many temples, priest doesn't want to provide the information. Priest used to shout at us because because they don't want to provide the information at what time the temple opens. Because the coming to the small temples, nowhere it is mentioned anyway. Like there is no opening and closing timing, no board, nothing, right? So, but we tried as much as, and the same thing happened in the case of travel agencies. There are many, so whatever visiting cards we could explore or whatever agencies we could explore from online, we used to contact them through telephone. So they used to tell that why we have to share all this information. What is the we won't share. Some of the travel agents were hesitant to share the information, like what kind of services they provide for the help of the tourists. They were hesitant. They were not ready to share.
Usually, when I visited like this track, so there was a clause that we shouldn't use LLM models to. Was there a specific purpose of discouraging LLM models? Because now we are going into LLM generation. Everywhere there is LLM. So the purpose of discouraging LLM is.
It is not like in our opinion, not discouraging LLMs. Of course, we used Llama to for the data augmentation purpose. So, not our idea is not to discourage LLM, but to restrict our experiment. But not to use LLMs. Other than LLMs, we were expecting.
Wouldn't LLMs, like even zero shot LLMs at some cases perform very well in such kind of tasks because they have, like, even let's say if you give a context and a question, right, it would be able to generate an answer, a zero shot LLM. But like if you have to go back to, let's say, transformer model, you have to train them and everything. So like if we have a solution,
I understand our co-organizer decision was not to go for it.
Like I face one problem with this task. Like you are providing like this context also. Then I have to ask question from that context. So this is, I think, it's very easy. Like if you are not giving that context, only question. Now I have to do something like crawl the all data from internet and like all who are providing the.
But that would again be a real challenging task because as I said, lesser known temples, lesser known information would be very difficult to guess the answer through online sources.
So in that case, it's better if you provide, like with all the context, provide a retrieval database and people can actually implement kind of RAG pipelines to you. Then you have a validated context there, and people can actually, because if you're already giving a context and a question, so it just has to search in the context and generate an answer. So I mean that's just a suggestion.
Yes, thank you. Thank you for the suggestion. We'll work on it. We'll work on it. Because this was the first attempt to join fire. Shall I invite next speaker?
Good afternoon, all. And presenting the building a question analysis system in Hindi language using word everything. So this is my presentation outline. Introduction, related problem statement, model schema, given the So question answering is an application of information retrieval and natural language processing that answers natural language queries. There are various types of systems. We define the question answer system in terms of various systems are already happened in this area. They primarily use the certain kind of machine learning approach, deep learning, as well as they use certain kind of transfer or model approach. They evaluated on the F1 score, U scores, and Rogan metrics. And these are the certain few related questionnaires, few related work related to the questionnaires. Then the problem statement is the main goal is to Vertica or organize a state task. In the Vertica state task, we build a question answering system that can handle the primarily in the Hindi languages. And they provide data sets in the Hindi languages, and these are the some statistics. There are training data set, validation, and they provide two test data sets, and test data 1 and test. And these are the some examples of the Vertica data set. And we use the word embedding approach with question similarity and with various kind of word embedding approach like what to make, globe, perplexed, and probably perfect with question similarity provide good performance compared to other word embedding approaches. And perfect with machine learning and also what to make model. Even if we use a TF-IDF models, but the performance is not good, so we don't put in the result. So these are the evaluation score on the test data 1 and test data 2. Among the test data 1 and test data 2, the visual perfect with question similarity approach provide the best view scores compared to other approaches. And in the test data, in the views, in terms of view score, the perfect with question similarity approach best performance. However, in the ROG scores, what to get model provide the good performance. And again, in terms of F1 score, the perfect with question similarity in view score and F1 score, both perfect with question similarity approach provide the good performance. However, the ROG score, the what to make model provide the performance is not so much different, probably quite similar. However, the fastest close question similarity provide the optimal. We are use ever means the primary reason we can think of that it can capture the broader contextual and structural similarity in the by the perfect model. And this is the conclusion. Our model provide a competitive performance to the other kind of models. In this study, we build the embedding based methodology for the building question answering systems, and we can okay.
I'm Sandeep. So this was one of my efforts regarding like how to use synthetic data to actually enhance question answering for small models. So it was actually done during my internship at Bosch. So first I was using working on synthetic data on factor data sets, and then why not we kind of decided why not work on some long form answers and see what happens. So synthetic data has a lot of applications in many words. Like if there's data scarcity, well, if the training data is not actually available, then we can try to generate synthetic data. And sometimes when there is a lot of bias in the data, like for example, the data is actually concentrated in some regions or some locality, but you want to expand it to some other regions as well, then maybe we can try to generate synthetic data in that table. And for actually enhancing small language models performances, in that case also we can use synthetic data also. And finally, in some novel scenarios also, we can use synthetic data.
So the pipeline is something like this. We have the documents, which are actually the content, the trend set content. Then we use the big models to actually generate synthetic data. The reason why we use bigger models is because we kind of think that maybe they are more trusted in that to actually give very high quality synthetic data. And using those big models, we use the context to generate synthetic question answer pairs from those training set context. And finally, after in the fourth step, we use that augmented training set to actually train a smaller model, like a 8 billion parameter model or 3 billion parameter model. And after fine tuning that, then we use that model to evaluate the QoC on the test and the validation. So the data set is something like this. We have the train validation test data 1 and test data 2. And finally, we have the synthetic data, which is using the context from the training set only and generating like around 37K QA pairs from. So if you observe, the test data 2 has questions which are kind of like more bigger than the other ones. And whereas the synthetic data has answers which are kind of a little bit bigger than the other. So the pipeline is something like this. So now that we have the augmented data set, so how do we actually fine tune? So I kind of wanted to understand whether we take all the data and fine tune, or do I take stage-wise fine tune? Like maybe I have the original training set, and then we use the augmented training set after training on the high quality data. So I kind of use this 3 pipeline strategy. So first I took this 13K original training set and fine tune Llama 3 8 billion on that, we get model 1. And then we take around 33K synthetic augmented data, which is produced by 5.4 14 billion. Because 5.4 14 billion was really showing very good results on academic text, like because it was kind of trained on academic textbooks and all those areas. And that's why I kind of thought maybe I'll use the synthetic data from there itself. And then fine tune M1 for 2 more epochs on the extra 33K augmented data. And then we get the M2 one. And finally, I kind of clubbed all the data from Llama 3 70 billion and 5.4 14 billion, and also take the whole training set and like club them together and train the this Llama 3 billion. So we get M3 after that. So I kind of wanted to understand what would be the best strategy. So just based on the validation data and the case data, I kind of got these results where the visual score was quite high for the original 13K data, which kind of suggested that the 13K data was like kind of very, very high quality than the augmented synthetic data itself. But on the case data one, I kind of found that the M3 model, which was kind of trained on the 50K data, was kind of very performing well in that. But during the TESDA 2 results, what we found was that our M2 model, which was kind of a stage-wise finding, first trained on the high quality data and then on the synthetic data itself, it got very highly scored in the QA. And also in two scores, we kind of got similar kind of results, but the synthetic data was kind of really enhancing the performance of the fine-tuned. So here are some of the samples. So if you observe here, so even in the so the main observation from these samples was that like I was discussing with yesterday also, like because we have the context and we try to generate data from it. What happens is that it comes up with create subsequences from the context itself. So, like for example, if you take the original training set, so while Bhagirath Kund is 14.1 kilometers away from the station, it is exactly like some of the subsequences from the first part of the training set, the context itself. So, if I actually give the context and ask the model to actually generate synthetic data, it will really go there in the context and start copying sentences or subsequences from there. So there is no kind of a reasoning involved in this. So then what I tried to see was that what I might want to use deep, which is kind of maybe maybe it will try to do some reasoning involved. So I tried DeepSeek in this also, where there was a context which had the prices of food. Like, maybe kachori was 9 rupees and this was 10 rupees. So there could be some arithmetic reasoning involved in the answering part and the question part also. So DeepSeek was able to do that, but the process, the process was too slow. Like DeepSeek was thinking for a long time and then producing output. So we kind of rejected that whole speed. So the future work is something like this. We have this diversity thing. In long form QA, this diversity becomes very difficult. I mean, there could be some long form answer which could be part of some other long form answer. Are they like do we even know whether those two answers are similar? We don't know. And another is the reasoning based QA generation. There could be some logic involved in the QA itself. Like for example, arithmetic reasoning or logical reasoning in the keyword itself, not just copying directly from the font. So that could be another of the filter works in getting synthetic data itself. And the third part is the filter strategy. How do we actually know the keyword generated by like the synthetic keywords are actually good or not? So do I actually go and trust a big model that yeah, this big model generates a keyword pair, hence is probably a very good pair. I don't know. So, and finally, there is some novel scenarios. I think my previous speaker already told us that the context were probably brought from the internet itself. Why not generate context from the LLMs also? Because the LLMs are already trained on this, probably the web search engines and all web text and HTML files also. So these bigger models like Gemini and GPT-4, they could also give us very complex context also. And these contexts might also provide a novel context out of it, apart from whatever is available in the internet. So these are kind of a feature works we want to do in future. So that was my presentation.
In this, I would be asking, it's not as coming to this, 50,000, increase the speaker. What if a native speaker of Hindi go through this data set and validate, there might be some semantics difference in the QA.
Yeah. Good. Yeah, that is what I'm saying. Like that is what I'm saying that we don't know how to actually filter out the good ones from the bad. Right.
So that's what our data set.
Yeah.
There are no semantics similarities, dating data or
Yeah, but we actually don't know from like previously, like whether how we actually like whether there are similarities or not. We kind of actually have this data set. We didn't even know that this was model generated or not, right? Then our idea was that we will augment the training set with synthetic data itself from the big model. That was our idea. So, validation is definitely different because why we didn't do the validation is because you can see when Llama and 5 generates answers, it is directly copying text from the context, right? So that is why we kind of thought maybe because the validation will take a lot of time, maybe skip that and see what happens. Any other question?
Good afternoon, everyone. I am here to present our work on Vatica shared task. So our work is called tourism and text space in the answering. So before starting, I would like to acknowledge that this work was conducted by Arya. She has been interning with us, but due to some pre-commitments, she wasn't able to come here. So I'm presenting her work on behalf of her. So starting with the I think the task description. Everyone before me also have been giving presenting what this task is about. So it's basically to extract precise Hindi answers from tourism related context paragraphs. Given a Hindi text and a factoid question, we need to predict the exact answer span, and the domain is of course for Varanasi tourism. So I'll directly move on to our methodology. So we employed two methodology as a valid run summation. First was generative question answering using MD5, where we use MD5 small, a multilingual text-to-text transformer, which treats question answer as a sequence generation problem. So we fine-tuned using question and a context as an input and generated the answer. So the main limitation behind this model was it produced fluent Hindi responses, but often defaulted to generic or fallback answers like उत्तर स्पष्ट नहीं है or there is no answer found to a specific question, which indicated limited effectiveness for low resource domain constraints. As the second methodology, we employed extractive question answering using XLM Robata, wherein we used XLM Robata, which is already pre-trained on Square 2 and designed a cross-lingual span-based question answering. So it predicts from the start to the end of the token positions. It tries to extract the answer span. We also, as a part of post-processing, we did sentence expansion and confidence filtering. So let's say if the system is not able to generate an answer with a confidence of 0.3, we tried to make it fall back to the default one. So based on run 1 and run 2, our model was fairly competitive amongst other teams. But as an ablation study, we also evaluated zero-shot chat GPT, wherein we only provided context and question prompts without any specific task-specific fine-tuning. We received a higher QAF1 of approximately 0.55, and it demonstrated that it outperformed almost all of the teams, and it stood second, I guess, in the leaderboard. So as a conclusion and future work, I would like to say that we did a comparative evaluation of generative question answering versus extractive question answering and zero-shot approaches that provided key insights. So out of generative and extractive question answering with XLM Robata for this particular task outperformed generative question answering using MP5. But overall, zero-shot chat GPT outperformed, I think, all of our generative and extractive question answering. As a future work, we would like to include hybrid extractive generative pipelines. Maybe we would like to try retrieval augmented question answering and open source LLM adaptation for domain specific. Thanks.
Are there any questions?
Harsh Mishra. Harsh.
You are audible?
Yes, yes, you guys are
Harsh?
audible. Harsh is online.
Harsh? Harsh, can you present?
Hello.
Yes, yes.
Hello, am I
Can
audible?
you? Yes, you are audible.
So shall I start sharing?
Yes, yes. The screen is visible. You can start.
Okay, good morning, everyone. Today, I'll be presenting Vatika, a Hindi machine reading comprehension approach for Varanasi tourism question answering using MT5. This work addresses the intersection of regional tourism and generative NLP for low resource languages.
Could you go to methodology part?
Okay, AI. Actually, the AI is revolutionizing digital tourism by providing instant, personalized information. However, there's a significant language accessibility gap. While English-centric systems are robust, over 600 million Hindi speakers remain undeserved in the current NLP landscape, limiting their access to digital travel assistant. So, our research identifies two core issues: a lack of Hindi dataset specifically for tourism question answering, and the failure of existing multilingual models like TidyQA and XWord to capture Indian cultural nuances. To solve this, we introduced Vatika, a specialized Hindi QA system for Varanasi tourism, leveraging the MT5, which is a small multilingual transformer. So the foundation of Vatika is its custom dataset. We identified 10 key domain categories, including temples, ghats, and travel logistics. Data was sourced through multi-source collection, including YouTube transcripts and field interviews. The final result is a curated set of 2,902 Hindi question answer pairs and noted for linguistic accuracy and cultural relevances. And in the model architecture and training strategy, we utilize the MT5 small framework, an encoder-decoder architecture which is optimized for text-to-text generative tasks. Our training configuration utilized the ADAMW optimizer with a learning rate of 3 into 10 to the power minus negative 5 over 5 epochs. We also benchmark this against the MBARD 50 model to evaluate competitive performances in a generative context. And looking at our data distribution, cones and temples represent our largest categories. Quantitatively, our model shows high alignment with gold answer, and error analysis reveals that 75% of responses are correct, with minor issues involving factual errors or hallucinations, which are common in generative transformers. So Vatika contributes the inaugural Hindi tourism QA dataset for Varanasi. We have proven that fine-tuned transformer models can achieve high precision in specialized regional applications, establishing the feasibility of culturally aware AI for low-resource languages across India. And for future directions, moving forward, we aim to scale this by fine-tuning larger models like MT5 base. We are also looking for multimodal enhancements, integrating maps and images, and deploying the systems as a WhatsApp chatbot or offline capable app to ensure accessibility for all tourists. Finally, quantitative human assessment gave Vatika a 4.7 by 5 for fluency and 4.6 by 5 for relevance. Evaluators confirmed that the system produces natural, culturally appropriate responses. So, thank you for your time. And I'm now open to any technical questions regarding the model. Thank you.
Thank you.
Yes, Raghav is here.
Rachana, Sharal,
Sharal, I'm here. I'm here. I'm Sharal.
please.
Yes. Can I present now?
Yes. Please
Yes.
share your screen.
Yes.
You can skip the introductory slide.
Yes, sure. I'll skip that. Okay. My screen is visible?
Yes. You can start.
Yes. So, good afternoon, everyone. My name is Sharal Coelho, and I'm presenting paper titled Hindi Tourism QA System Low Resource Question Answering Using MT5 Small. So, the authors of this paper are Asha Hegde and Amrit Kala M. Shetty, Muhammad Zahir Talje. So, I'll directly start with the methodology part. Um, so here, this is the general framework of our proposed method. We got a JSON dataset, I mean JSON files, and initially we converted these JSON file into structured tabular form with the question, context, and whatever answer fields were given. And we have applied text normalization. So for text encoding, we have used MT5 small encoder decoder architecture as a tokenizer. Here, basically, the MT5 it is a transformer sequence to sequence model trained on huge multilingual corpus of over 100 languages. So here in the model construction, so the proposed QA system uses a Hugging Face transformer library with the sequence to sequence trainer for both the training and testing. So the model accepts the tokenized question or the context pair as an input, and it produces the respective answer sequence as output. The decoder generates the answer as a natural language text, because here we have given the Hindi as our input. So here we got a Hindi answer as output using greedy decoding or beam search. So the generated tokens are decoded back to human readable text, and whatever special tokens are removed to obtain the final answer. And the training environment involves early model checkpointing, and validation was done using blue scoring. And whatever best model we got, we saved as a based on evaluation loss. So these are the we have did some hyper parameter fine tuning here to prevent the overfitting. So this is our result table for performance of the proposed model on test data 2. We got less result only here. When we compare to other participants, we got somewhat I cannot say it is the best one, but we tried to give a best result here. And we got blue one score 26, and Rouge one we got 0.0128. So these results shows that domain adapted multilingual transformers that can successfully comprehend Hindi questions, and it retrieve a relevant information and generate accurate answers. So here to conclude my work, we fine tuned multi AMT5 based model, achieving blue score around 26. And our future research is we want to incorporate domain adoption strategies, curating larger and more diverse data set, and investigating hybrid retrieval generation approaches also, to get further robust improved result. So these are the references, and with this I conclude my presentation. Thank you.
Thank you, Sharal. Okay, now I request Asha ma'am. Are you there?
Asha and we both are in the same team, sir.
There was a paper ID 32. I think it is a duplicate. 68 and 32.
Sharal Coelho and Asha Hegde.
Rachana and Sharal was another paper.
No, we had only one paper. Yeah, I submitted one file.
All right.
So there is nobody else in online, I guess. To answer Krishna's question, co-organizer sent the message that open access LLM model only restricted as the data comprises some personal information of sources, like uh, personal information in the sense travel agencies contact numbers are there in our database. Okay. And whereas the closed LLM were allowed to use, like the case of Sandeep, we were looking for a solution which can be implementable in real time. Maybe in, but it couldn't happen in this task. For future data. So I, from my bottom of my heart, thank the track organizers, fire organizers, IIT for giving me this opportunity. And in this context, I acknowledge Institute of Eminence, Banaras Hindu University, who provided the grant to take over this project. And because of it, we could come up with this data set. Thank you very much. Okay. So we have lunch break now. Till 2 o'clock. From 2 o'clock, we will start our conference track. In conference track, there are 3 papers, and there is one track presentation also there. Person not come here in person yesterday because of the flight delay. So he will present CMIR. Uh,
Williams and the L'Oreal with Unilever based on the average the enterprise value divided by EBITDA over 3 years. So of course, it's not very simple. So so you have to train a very large customized model to convert that, generate that BQL query which says for these 3 different tickers, get average, field and race, right? So that's a lot of work goes behind to get the right generation. And moreover, we can actually use chain of thought prompting on top of it. So we can actually say that show me alternatives on the right. So we have a query here. What are the largest companies for market cap? So it's very simple. It did generate some queries here. And then if I actually talk back to it and say show me alternatives, it's going to show me other types of queries give you similar data. So you can actually have a dialogue with the query builder. And in fact, you can ask it to explain the answer. It will be, why did you give me this query back? Then it will actually tell you that this query aims to retrieve monthly return, and these are the different components, and that's the reason I, to build the queries. And so we want our system to be explainable, interpretable as well, not just black boxes. In the finance industry, I think it's probably number 2 after medical sciences, where having some interpretability and explainability of safety is very important. Obviously health and medicine, I think, is probably one of the foremost, but finance people are betting their investment, it's creating large amount of money. So you don't want to create wrong answers. The safety is a big concern. And again, we have also generated more sort of typical information discovery pipelines where you can not just connect to the Bloomberg query language, you can connect to the Bloomberg system as a whole, where you're not looking for just data answers back, you're looking for like commentary on current answers. So you can talk to it, have the text sectors. How have the text sectors done in the past week? And it will, like, I said, augment this Bloomberg and it can easily generate that. Okay, so the next part of this is the more recent work we have done is what we call agentic AI. One of the things we discovered is that if you just build a large language model like Bloomberg GPT or other, and just throwing all of Bloomberg data into it, it's actually a good exercise. It works well, but it's not the optimal solution because Bloomberg has built over 30-40 years very specialized systems for very specific tasks. For example, the BQL is a great example. BQL is a specialized system already, so we don't need to go from the LLM model directly to the data. We want to go from LLM to the BQL query first, then we let the query be answered by the agent, the BQL agent. Similarly, if you have an agent for starting or visualization, you don't want to reinvent that using language model. It's more complex, more error prone. You already have Bloomberg has a system for visualization starting, with lots of amazing features and specifically customized for charts. So there's no need for training an LLM to reinvent all of it. What we are doing is we are telling the main sort of orchestrating LLM at the top level, find the right agent that can solve it. So we don't want LLM to take on the very burden of solving everything by itself. It has benefits. We get to use expert systems. We reduce errors, and it also is more explainable, more understandable for our users. Because it's more familiar as well. So this is the agentic AI framework. We try to leverage existing systems in Bloomberg. We want to discover all the existing libraries of functionality. So there's a lot of financial libraries which are, very complex pricing models. You don't want language models to solve equations for your data. So you want it to make call the right API to the agent, and so on and so forth. So yeah, we know that this is obviously the next generation, and it's already happening in Bloomberg. Makes it much more powerful. We have seen great feedback from our clients who say that this is a great use of existing systems that they were very familiar with. And they can also port it. What's also very convenient is that they can actually port the output of this LLM model into those systems, agents which are already there, and then they can save their results the way they used to. They can monitor their portfolios. They can do all of the other sort of lineage tasks around that query, without having this black box answer. There's no connection with anything. Right. NLP capabilities at Bloomberg. Sorry about the spelling errors. But of course, all of these things are very popular. The two things that we tend to focus on from our team. One is topic classification. Second is sentiment analysis. Because we actually have big NLP team, Bloomberg, NLP, and they actually build the infrastructure for the language models, and they do more the NER, translation, summarization type of work. We do the work which is relevant for potential quantitative trading strategy. So any type of derived data that's useful for building portfolios or useful for building a trading strategy, where we tend to be. And we have found that sentiment analysis, as I mentioned, is very popular. Very classic case of building a strategy. Certain names are showing a positive sentiment. You would want to go long those stocks for a short period of time, go short stocks to negative sentiment for a short period of time, and can show that strategy can create reasonable return. The key is to do this diversification across stocks. So if you just take stories, news stories just for one particular company like Microsoft, it may be very noisy. Right? You may get sentiment of Microsoft as a large standard error or noise around it. You may not get enough signal in it to treat the noise. But if you go long all these stocks which have a positive sentiment, you go short all the other stocks that have a sentiment, you are diversifying cross-sectionally. So essentially you are reducing the variance of your expected return. So concept called Sharpe ratio in finance is the return divided by volatility for variance. So the lower the variance, higher the Sharpe ratio. And diversification allows you to lower the variance. So we always recommend use outperform in finance, but try to diversify the signal as much as possible, whether cross-sectionally or in time dimension. There are many different creative ways to build portfolios that can use. And topic classification is another very good example. I will go into some details with that. There are certain types of topics. Okay, let me step back. So Bloomberg has a large dictionary of topic codes. So every particular news article or analyst story gets tagged with all the different topics that are present in that story. So this is also done using a different lines where we map the content of the story into this thing, like hierarchical tree of topics. Which is now earlier you were doing it for more traditional machine learning methods. So once you have found the different topic codes in every story, and what we have discovered is that certain types of topic codes are more important or more sensitive for trading than others. So if the topic, for example, the topic is around some controversy about the company. That tends to be much more about legal issues or maybe like some sort of environmental issue, which is more about the kind of the maybe a class action or a patent IP. It's definitely more about the active case, the legal case companies facing than the company's performance in the job. So those topic codes are not important for it, but if you find topic codes such as analyst recommendation or the company news topic related directly to the performance of the company, and you kind of amplify the signal from those topic codes, then you will get better trading. I think that's right on that. So, and as I mentioned earlier, you can't see all of that, but basically, this is an example of a tweet. And we have identified all the different entities mentioned in the tweet, whether it's Facebook, customer, another company, and people mentioned, and so on. So we maintain this knowledge graph within Bloomberg that allows us to do all this mapping. Again, there are some specific things that only like Bloomberg or similar financial services can do, like sticker mapping is not something that a tech company will be expert in. So it's very much like the very highly expert for finance. So that's sort of our competitive advantage on top of the other companies. So one project we have recently done actually on Reddit data. So social media is very popular. I don't know how much Reddit is popular in India, but it's not. It's very popular. There are so many what we call armchair experts. So we find advice on anything you want. A lot of subreddits, channels, the financial world, which are talking about investing or personal finance or economic news. And we want to again use their data to drive some signals, right? So again, like this at the bottom, you see somebody is saying 100% of my Roth, which is a retirement account, into NVO, which is a company. And told my that's not showing UNH there. And YOLO is just a so I think they type whatever they want in the Reddit post, right? So and sometimes they also share this screen here. This is a screen from, let's say, Robinhood or their brokerage platform in an image format. So we have to do OCR for that. So that part can be done using OCR, and then if it's in the body, we do it the regular way, and then we map it to the right entity. So that's a very strong use case of, if you believe the signal in Reddit, which is controversial, but there's definitely a lot of activity, a lot of chatter. So we have to keep a watch on it. So we built a very specialized, NER pipeline for this. So essentially, we wanted to try out a few baseline models and then a large language models. So first of all, we have data coming in 3 different ways. One is the images from the screenshots. We use OCR for that. Then we have Reddit posts and also that are available. Sometimes there's a tagline that they have. So we have to process all that. So we basically built two baseline models, what we call direct and bare. So in finance, many people will, when they're posting on social media, they will prefix their name of the stock with a $, like such, like APL with $. So those are very easy. That's like very lexical, simple way to identify. Otherwise, some people will actually use the actual ticker name, but they will not put the $. So that's another common use. And otherwise, they're just writing Apple as a word or Facebook. Those things are more nuanced. in terms of the discovery, because we have to map it to the right ticker. In the other two, the ticker comes for free directly. So we actually running these 3 different models on all the posts, and then we ensemble them in different ways. So you can do like a best of or an or, like, you know, basically whichever one gives you some discovery, you will take it, or the best of 3 type of model, or a combination. But these are also probabilistic outputs. You can do a regression model to build like combination of all the different existing candidate models. Every possible. So these are about 50,000 possible companies. Yeah, and some of them even have like common English names. So the ticker itself will be like ALL, all, but it's actually also a ticker. So you can imagine the kind of thing they will use. So you have to really do a lot of specialized rules based as well as language training based. Yeah. And essentially, what we are shown here is that we, on the right hand side, we can see that we use this our approach, which is in green. We actually pick up more. We have more recall. So number of posts with mentions of particular discovery go from 350K to about 400K. So we are able to capture more of the information, tag it. Sorry, that's the customer file. We go from 350 to 500K. And then on the green, on the right hand side, the average tickers per mention. So that's taking how many people, every post could have multiple companies. So sometimes in a single post you have 2 or 3, you have to extract all of them. So especially for that, our pipeline is very useful. Be able to get 2.4 figures post. And one of the driving factors for that was the images data. So you can see the biggest lift was from image. So this is not in the classical pipeline. So most of this lift that we're seeing from classical to custom is actually coming from the image data. Not all of it, but more. And another type of scientific information we have to do is at the product level, so at the retail product level, which is its own animal, right? So tickers are complex, products are probably equally or more complex. So you know, there's a Reddit post about and you should be able to identify that third of the product and brand the product. So you have to be able to identify those, recognize those, and then map it to the right category. So we have again a big taxonomy of product classification. This is a taxonomy of. It did not. Oh, there it is. So this it's not very legible, but it's just like you know, it's called a tree map of different categories. So you can see this you know, within each sector, industry sectors, the different types of products. So like, you know, travel has products like hotels or airlines, and so on. Home and living has tools, home decor. So there's a very big economy that Bloomberg kind of curates that maintains. And we have taken the raw textual data from the Reddit post and map it to the right segment of the tree. And that's also done using a large language model. And we go back to it's where we found that you know, we had to be more creative because we could not use the existing open source large language models. We're dealing with about 1 million Reddit posts and about 5 million or 10 million comments. And we want to be able to process. Because we want to build it, any other pipeline can be quick enough. Like it should run in a few hours, not like 2 days. So use any of the standard models here at the, if you leave the first one out, all the rest of them have on a logarithmic scale, you can see they are processing around 100 to 1,000 tokens per second. And then if we replace it with our own new sort of, let's say, candidate language model, we call it mini-LM because we want to reduce the size, we want to use distillation to reduce the size. And you can see it's about 2 orders of magnitude higher per second. So we're talking about 10,000 tokens per second. About 100,000 compared to the best one in the large language model, 40,000. So we can cut down the time by a factor of 100. And that's very important. So now the challenge is how do we train that new model? It has to be built from scratch. So we actually did a more standard sort of typical machine learning training pipeline for that, which is curating some human samples. So it's not just in the academia we have keep graduate students for labeling, but sometimes we find them in this. A lot of data for us, and then we train this small language model. So essentially, it's a model to clone our best model. So we're training a small model to become as close as possible to the best model that we create first, just to make it more quicker to run. Yeah, I can. But yeah, of course, there's a lot of care to be done, especially with like concerns on overfitting and things like that. So the traditional curve of training loss versus validation loss. So you have to train that and make sure you stop at the right number of epochs and you have a good model. And it turns out this model again at the very top we have the new model, which is our mini model versus all the large models. And we see in terms of performance, so now we are comparing recall, precision, and affluent scores. It's actually even performing better than other models. So it's not just efficient, but it's actually kind of done it become very customized to the type of problem we're solving. So we're happy to do this fine-tuning efforts instead of just using an off-the-shelf model. So this is a way to get 100 times speeder, also somewhat better transfer. All right, so the next part of my talk is maybe something controversial. This kind of goes back to maybe what Master was talking about in his keynote speech. So one of the new projects we've taken is to understand biases in the large language models, especially around geopolitical boundaries. So we know that there's many different types of concepts which can create a bias. So territorial views. You have a model from China, you never talk about Taiwan at all, right? Because it's China. But depending on the lineage of that model, there may be different cultural grounding issues or language issues, and we want to know the impact of these types of potential biases for financial use cases, because we are trying to extract things like sentiment and using that for trading. So if our sentiment signal is affected by this kind of biases, we have to understand that maybe even like correct for bias if we can possible, or at least use some tools to remove some of the segments that we know the bias is very high. We ignore that, for example. So yeah, so this is just to show that it's kind of well known that AI models do have particular biases. So if you look at all the big tech companies, except the one from X or Twitter, if you look at Meta's model or Claude, or ChatGPT or Gemini, they are mostly left-leaning. with a more right leaning. Maybe Gemini could be more centrist. So I think politically there is some biases, and it can translate to bias against the country, right? So when we are analyzing, let's say, posts about stocks or companies of a certain country, we don't want that bias to creep into our financial analysis of that. So we have to be very careful here. And yeah, I will not go into this. I think there's some delay going up, but because some dialogues we did with different models where we asked questions which were politically charged. I guess should US have strict immigration policies, and you got the answers that you thought they will. I mean, they are biased. So Grok said, no way. We should. Grok said that we should have protect the borders, and all the other models were like, no, we should be more liberal. So clearly it's there. So I don't want to talk about that aspect. But what we are concerned about is looking at sentiment analysis by country and by topics, and we see that actually most models tend to agree. So these are the average sentiment scores across countries. Most of them are positive. I think that's typical for these kind of large models. They tend to be more upbeat in general. And there's some variation, but the variation is consistent across multiple models. So we were happy to discover that there's not so much bias, at least between models. And the topics also are showing the right trend. So bankruptcy is negative, job curse is negative, dividend curse is negative, which makes sense. And analysts raising the price target or a buyback are positive. So those kind of make sense. So we were happy to see that there's not so much of explicit country or topic bias, but we did actually discover a language bias. But anyhow, one thing I wanted to sort of use for the next couple of slides was this way to represent sentiment data. So when we classify sentiment for our stories, we actually produce a trinomial probability density. Different classes, neutral, negative, and positive on the right, and they actually can be represented. The actual output of a sentiment analysis model, which is the probability density, comes to 1 across the three classes, will be a point inside the triangle. So every sentiment that you get from the story, every news item will fall somewhere in that triangle. This is a very good way to represent sentiment data. And then we look at, let me refresh. We look at different models and their sentiment outputs. So we have seen here on the top here the mini model GPT, this is the 4O large model, Llama 70 billion and Llama 8 billion, and so on and so forth. So you can see that if the density is kind of uniform or spread throughout the triangle, that means the model is giving you sentiment outputs across the full range of possible outputs. But if it is leaving out a big white space, that means it's biased towards one vertex or one edge, which is problematic, right? So the Bloomberg model here, because it was sort of built using a custom pipeline with our own but it has more bias than the 8 billion model. This is I have a conjecture for that, which is that about 2 years of models were developing, the very initial feedback for the inside, they were asked to be more confident or more clearly stick to one of the three classes. So that's why you find that the 70 billion model has most of the points across the edges and not in the middle. So that approach is a problem, right? We don't want to have that bias affect our answer. And we see a little bit of difference across countries as well. So India, US, China, Germany. So again, I'm comparing the Bloomberg model versus the small Llama model, which was the best one from the large language models. And we see that even compared to Bloomberg, even that one is a little bit more white space, right? So the problem. So we are trying to understand. This is ongoing. We're trying to understand what if we can synthesize the correction term for every category, like country or language or industry, and apply it to the output of the model to generate more bias-free results. This is another way to visualize where we actually take a small subset of just the positive stories of Bloomberg. We can see that the Llama model puts them all throughout the map, which is not great. So it actually works for US, at least for China, it mostly put it on the right side, closer to the intended output of the bottom right quadrant. So we can try to understand these various nuances and cross sectors. Once the brushes, you see healthcare versus government, the different type of bias, and this is more of the China bias. So yeah, I can speak openly here. It's not necessary. Yeah, we are all very. It's all very clear that we expect it to have strongly pro-China. So on the left-hand side is pro-China, on the right-hand side is pro-US. So DeepSeek, no surprise, it has a more pro-China bias, but OpenAI GPT actually has the highest pro-US bias. So this is comparing the sentiment of countries. The countries or companies in those countries. Very useful to and in terms of trading signal as well, we want to actually build trading signals which can be very effective for a quantitative investment strategy. So here what we've done is we've taken the sentiment scores from different models and we have bucketed them into 20 buckets. So each bucket represents about 0.1 of sentiment, and we have sentiment going from -1 to +1, from negative to positive. And we can see that the Bloomberg model at the very bottom has this very nice sort of trend where the most negative sentiment also has on the y-axis the most negative return of the stock. So it tells you that once you observe a negative sentiment, the next day return has to be negative. So you can invest based on that strategy, and you will have this kind of nice performance throughout on the very bottom chart. But if you look at all the other charts or the other models, so this is the Bloomberg model and it was hidden here, but these are all the other models. You can see the trends are not very clear, except on the edges where the most positive sentiment has. Okay. The most positive sentiment has the positive return, and the most negative sentiment has negative return. But in the middle is a hodgepodge, not unlike the Bloomberg model, which has a nice linear trend. So you can see that clearly based on the data, the Bloomberg model will give you best performance strategy. All right. So I don't know how much time we have. What, 5 minutes? Yeah. Okay, I'll try to wrap up. So the topic modeling is also very important for Bloomberg. As I mentioned, we tag every single news story into various topic codes that are present in the story. So this dictionary of topic codes can be very large. So I think it's about 5,000 topic codes that we have Bloomberg. Going from, let's say, tariff can be topic code for war or economic news, so COVID. All these are topic codes. What we are doing here is we want to understand, sort of topic themes or topic clusters, and not just each single topic individually. So what we try to do is we take a look at the entire news corpus data. So we take this matrix X. It's a very large matrix with every row being corresponding to one single news story. Let's say 1 million news stories. and along the column is the one column for each topic course. So let's say we have 5,000 topic course, so we have 1,000,000 by 5,000. And most of it is sparse because each news story will have maybe 10 topic courses or 15 topic courses, not all the 5,000. So it's a very sparse binary matrix. And one way to build topic themes or topic cluster is to use a factor analysis or a PCA method, which is very common. But it turns out it has a flaw. So, but if you use a standard SVD or PCA method, you will find that it tends to build factors or build clusters which have too much membership. Each factor might have like 50 or something. That's not really the standard. Cohesive as one theme. You want to have a low membership clusters, low membership themes that are actually corresponding to meaningful clustering of a topic. So for that, instead of PCA, we use a technique called ICA or independent component analysis. We actually combine the two. That's why the name is PICA or pretty independent component analysis. So essentially, we are taking the PCA factors and we rotate the PCA factors to make them more independent. So I think this is maybe important to grasp that what do we mean by independence, right? It's a very loose concept. So it turns out if you have lots of independent signals in general, and when you combine them together by central limit theorem, combine many different signals, you will end up in a Gaussian signal. Very relatively, right? So PCA, because it's mathematical variance, just works more in the Gaussian sense. But if you are trying to capture more of the independent signals for combination, you have to, one of the properties of the independent signals is that it will have very high kurtosis or fat tails. And when you combine them with the central limit theorem, you get this Gaussian, you will have zero excess kurtosis. So one way to identify whether you have independent signal or not by looking at the kurtosis of that. If it has high kurtosis, then it's more independent or more kind of driving or a draw factors. If it's closer to zero, that means it's more of a combination or a synthesized. So essentially, what we've done is we've taken the old, the PCA factors and we rotate them to maximize kurtosis, and we discover themes which are much better aligned. And yeah, this is kind of the explanation behind it. I don't have time for that, but yeah, PCA essentially, looks to fit every data into an ellipse or a circle because it's just looking for dimensions to explain most variance. It does not understand independence, so it's just looking for. So if your data is just a cloud, it actually can't tell which factors are, which is the factor number 1, which is the factor number 2, because it looks the same to it, right? But if you have data which is a little bit different, let me show you along these lines. So clearly you have 2 different factors here, but because PCA is just doing maximization of variance, it will still be confused in terms of the construction of the maximal variance factors. So these types of data will only respond better to ICA than PCA, and we can see that this is a result of that where we show the membership of the clusters across the stories. So we actually show that in the blue is the PCA factors and in the red are the ICA factors. So we show that the PCA factors, each single factor is explaining too much of the news corpus. So 10 to 20%. 10 to 20% of the data is in a single factor, which makes no sense. Also, number of topic codes in the blue is like 50 to 100, which is too many. But if you look at the red ones, we have very low membership. And those are very clearly understood to be meaningful topic themes. So that's how we build topic themes, and then we trade on topic themes, as well. So another use case we've done is like estimation of geographical exposure from the earnings statements. So we are capturing what the company discloses on their earnings statement in terms of what countries they have exposure to, and we build this pipeline of traction whether statements mentioned in company earning statements are positive or negative for a particular country. So you can select the country, China here, and you can see the actual statement in the document, which is either positive, negative, or neutral for that country. And it helps you build a better estimate of the country exposure. Similarly for other countries. I think that's probably yeah, this is kind of similar pipeline for financial documents. But so yeah, my conclusion, I think politics again was more of like a kind of a showcase of different things rather than a single topic. But I think there's a lot of takeaways that you know, you can't just take the big tech models. You have to at least for Bloomberg, or if you are you're trying to build expertise within a very narrow segment of industry, you should really use the deep domain knowledge to sort of fine tune those models and build additional capabilities. RAG is those pipelines like RAG are essentially perfect to use them all the time. And in addition to, we are also trying to, marry different disciplines here. So, quantitative finance, machine learning, NLP, we're trying to use like approaches from each area to cross-breed, new creative ideas and projects. So that's very exciting. Yeah, agentic AI is the most latest scalable paradigm we are using, and yeah, and this, Bloomberg carries a lot of alternative data. So I showed you only Reddit. Reddit was obviously big, but we also have data from prediction market. There's a betting market for many different types of outcomes in all kinds of areas like sports or elections or economics and even culture. Whether Taylor Swift will get more than 1 million records sold or not. There's a betting market for that. You can go and bet on that. So we are actually trying to again synthesize information and derive data from those markets and make it available to our users. All right. So thank you so much for your time. Hopefully there's one question.
Yeah, maybe two questions.
Yeah, I'll be here after.
Yeah.
All right.
Thank you, sir, for a nice talk. It's the role of linear languages or where you place them. Here in India, they are 144 population, and when you schedule languages, like in a non-scheduled language, 121, 22 to 11, right? Of course, there are other. Don't you think so? That these languages are contributing to the GDP of the growth of and economy is generated through Indian language. So where do you place Indian language in your talk?
Well, in the financial world, there's no, not much financial news that's already, all the outlets of financial news are.
Like what if a simple question is, if I want to do investment on e-class in English, but I don't know English, how do I invest and grow my
That's a great point. I think
a simple question. No, I
think Bloomberg hasn't forayed into that space yet because I think that for them business, right? So they have enough English speaking audience even within India to capture first. So they will probably move on to that. But it's a great point. I think yeah, we should really do some some proof of concept for that. Show that we can at least the main ones, not the very low resource ones. So
pulling information and Reddit because we Reddit is here. I mean, I don't know.
Yeah, I don't know how much of Reddit is in Hindi.
I mean, it's
No, it's all English.
It's like
English. Yeah. Yeah, we'll be happy to look at it. I mean, this is not the scope of my project, but yeah, I know it's something we should not ignore, I think. So, yeah. Okay. Yeah, absolutely. I think it's a very good point. In fact, if you just look at purely the sentiment itself, it's very, very short lived signal. Does not last very long, just fade daily. But if you combine things like it's called publication fees or under readership, volume, and then I think the first more median of signal, but combining percent. So we actually have done a strategy of we actually did a two-factor model with sentiment plus news, and that's made that over with. Take a big oh, yeah. Sorry. Fantastically, the best talk for lot. Thank you so much. I was scribbling notes down. I was taking pictures. I really enjoyed that. Thank you very much. Yeah, more focus on the. Thank you so much. Thank you, Mike. Sorry, I mentioned really for the details of sitting night. And so we have the link on the tables now. And then we have the that. So sir, one track presentation. Yes. Okay. Yeah. So yeah, OG. You already shared, no? Yes. So good afternoon, everyone. So I am Madhukar. Okay. So I am Shubhadeep Bhatta. I am in front of you to present my work. Actually, it's a collaboration between our SMU and NIT Agartala. So my work title is a multi-model lexical approach with fusion for code mixed information retrieval in CMHAN 2025. So the organizers already provided with the introduction and the dataset details. So I will be starting with the motivation that why did we start.
So the first thing is code mix social media queries demonstrate spelling variation and noisy way. So the data set was in Bangladesh. So we had Romanized English letters. We had some words in purely Bengali script. So the problem is while we extract information, the lexical models or any model cannot just rank documents uh, purely due to these models are not trained in Bangladesh or the low resource languages like Bengali. So they are purely trained for standard languages like English. And the second point is simple lexical models struggle with term. So in the data which was provided. Coming to the methodology, first input and pre-processing. So we tokenize the data and use Slang normalization And finally, we came up with an idea, Rapid First, to handle minor spelling differences. So we made a line dictionary which will be matched with the proper terms. Means the Bengali words like K or AJK. It will be matched with today in both cases using a dictionary. Use Rapid First to handle minor spelling differences. So it will generalize the variations present in the dataset. This Rapid First uses level distance to calculate the variation. Secondly, we use multiple lexical retrieval models like PM25, PFIDS, PN2, and others. So it creates a robust kind of model which is not dependent on a single model like PM25 or Colbert. And at last, we used reciprocal rank fusion to combine these results and come up with the actual ranking, which is stable and reliable. So uh, these are the results. So according to the leaderboard, our mean average decision score makes us stand fourth in the ranking list, and our NDCC score is the second. We got a pretty good NDCC score as compared to other teams. Uh, yeah, so uh, these are the results that normalization helps improve lexical model because the data is inherently very noisy and it has very much variation, and social media slangs are very context dependent. So each word means very different in multiple contexts. Then our multimodal fusion outperforms individual retrievals, indicating complementary strength. And thirdly, our metrics like NDCP is very strong, as I told earlier, just compared to others. Error. What we found out that spelling and romanization errors, like as I told, the same example is given here, and coming to ablation study, it could not be completed because of the absence of final URL, which is not provided by the organizers. Uh, then normalization remains incomplete and ambiguous. We can add to that different to make it more robust. And finally, used for evaluations were noisy. They were automatically generated rather than manually and so we need the proper tutorial, the future scope, expanding the normalization dictionary can help make the model more powerful, more accurate. It can increase the score. Can pseudo-plural generation in multi-model extent can reduce noise and bias by selecting relevant labels only when multiple retrieval models consistently rank same documents highly. And thirdly, evaluating the system on larger and more diverse data. So to make the model more accurate, we need multiple data sets from different domains. We need thousands of more columns, queries, and data. And lastly, domain adaptive retrieval. So we need data from particularly different domains like social media posts, news articles, comments, someone mentioned Reddit post. So we need to train the model using various things. Feedback and learning. So hybrid retrieval works better because it combines the strength of lexical and semantic approaches. Yeah, as I said, it performs better than using a single model like PM25 or any other like dense retrieval models. Normalization is critical for handling noisy data. If we use these kind of data sets like social media text, so we need to do this normalization to better pre-process the data. Lastly, evaluation must be performed with caution when using tutorials, as relevant statements are automatically generated and may contain noise or bias. I conclude my presentation with this. You can scan QR code to get the Python notebook that is provided. So, thank you. Any questions? Okay, thank you. So now, the conference paper presentation. Anish, this paper title is Dynamics of Character Embedding in Indian Mythology. Good afternoon, everyone. I'm Anish Goswami from IEM Kolkata, and I am presenting my paper of dynamics of character embeddings in Indian mythology, a physics-informed neural network approach. My co-authors are Professor Apurva Paul, Dr. Shainik Kumar Mahato, and Dr. Dipankar Das. So, the dynamics of our paper dynamic embeddings are done on text like which are rich in culture and heritage like Mahabharata. The characters we have chosen have evolved across purpose and chapter with roles and relationships. Now, this BOT model is actually kind of a black box, and we are trying to uncover the mechanism by putting 4 additional layers of metadata so that it provides a continuous sheet rather than a discrete one. So we have chosen 6 characters. The characters are Arjun, Karna, Krishna, Yudhishthir, Duryodhan, and Abhimanyu. These 6 are the 6 major characters which can be chosen, and the BOT embeddings are collected across 12 layers, and 11 transitions are made. Like E is plus 1, so 11 transitions are made for the 12 layers. And the metadata we are providing is for Parva index, chapter number, and sentence position. Therefore, the whole data set makes 12,000 transitions. This is a glimpse of our data set as a whole, and this is how our data set looks. This is just the first one. Yes. Now, BOT has 12 layers, and we are performing a gradual shift across it. The meaning should not change drastically across the layer. Like if you follow a pattern, and it should be steady, not like a sudden change, which cannot be like interpreted or justified. So we are trying to perform a smooth
smooth embedding, smooth output to the solution. So we have 768 dimensions of bird, and we are adding 4 layers to it to understand the mechanism. So our hidden layers include 256 units each. Its activation function we have used is JLoop, and the output layers is 768. It is reduced from 772. And the purpose of this network is to act as a small transformation network between the input and the output layer. And this is a model architecture. We are creating our data set from scratch. Actually, it's a publicly available data set, but the annotation is done by us. Next, we are designing the pin, and we are adding some constraints, that is for smoothness, norm consistency, and narrative semantic properties to get a smooth trajectory. Then we are doing the model training and the aberration studies to confirm the results, and then we are analyzing and providing insights about it. So in our training setup, we are using Adam Optimizer with batch size of 128 and running through 100 epochs. The learning rate we have kept it 1 e to the p minus 4. Yeah, this is our results we have obtained for the 6 characters in DH1. This is not in the slide. Yes. Okay. Yeah. And this is the graphs for the training. We have obtained the losses, the loss functions that were there, and the above table shows the MAE and the cosine similarity. It means the how much it is matching with the original dimensions. And this one is for the this one is for the aberration study across for all the characters. We have used 5 of the most popular metrics like MAE, MAC, R-square, cosine similarity, and Pearson's correlation. Yeah, and this one we are checking for the first one for the full data set. Then we are using for first to 6 transition. The next one is for 6 to 12 transition, and E3 is for the odd transitions, and the E4 is a custom randomly chosen one. And these are also for the same 5 metrics. Now the results show that most of the characters like Arjun, Karna, Duryodhan, and Yudhishthir attain a cosine similarity greater than 0.95. It interprets that the semantic similarity is much higher, but one thing is that Krishna, although it has got a lot of data, but it still underperforms. It is because it is the diverse characteristics across the text, and we can infer that the early layers, like from 1 to 5, 6, the transitions are easier to model and change consistently. But in deeper layers, it becomes quite a task recipe. And in conclusion, I'd like to say this is one of the first continuous semantic model that is developed on any Indian text, and it is actually made to capture smoother dynamic and to understand the metadata dependence on it. And we have found that surprisingly the metadata we have used had little effect on the later layers of transition from approximately 7 to 12. The impact was much lesser than 1 to 6. Okay. Any questions? how these dynamics are helping to understand that
Actually,
you're telling semantic similarity. What does it mean?
yeah, semantic similarity means how the means if we plot the original embeddings and try to predict it with a model like pin, how closer can we get to the original embeddings? Like if we use like simpler neural networks or logistic regression, it can sometimes give way off results than pin. And pin is one thing of means good thing of about using pin is that it uses much lower resource than other traditional deep learning models. And though it is it's much more complicated than logistic regression and others easier performing neural network, uh, Pin gives very good results on lower resource data like this Indian text.
What do you say?
Actually, for Indian text, I think nobody has done. Like we are like these six characters almost represent the whole of that Mahabharata. It can this word can be like extended for other Indian texts like Ramayana or any other foreign text also, which doesn't have much resource. So that.
Any okay, so thank you. Now the second presentation is prosthetic features as banking signals cross-lingual speech summarization in Indic languages by Priyanjana Chaudhary.
Good afternoon. I am Priyanjana Chaudhary. I'll be presenting my work on prosodic features as universal rank signals, cross-lingual speech summarization in Indic languages. My co-authors are Professor Sanghamitra Nath and Professor Sharma, and I was a part of my certificate university. So, summarization. Summarization is basically condensing extracting the salient information, the most important information from a document and condensing them into one shorter form, which would help us in readability, which helps us in browsing, and which helps us in viewing the document with text or in short time. So summarization. So summarization aligns completely with the information retrieval problem. So information retrieval is basically getting the most important documents by finding the salient information and then ranking those documents based on their importance and then showing it. So for summarization, the query is the document itself, and we rank the sentences that we have. We find out which sentences hold the maximum information, the most important is for the information is more loaded in those sentences, and we rank those sentences and then they are condensed and we form a summary. So summarization and IR goes hand in hand. So therein we have speech summarization. So speech summarization is again summarizing a spoken document. So, for example, we have a broadcast view session of 15 minutes broadcast view session. The summary of such a broadcast view session would be a 30-second highlights of that in audio form or probably in text form, depends, but from directly from the the broadcast news, or let's say a an audio lecture of 1 hour, we want to hear the main highlights of that lecture. Let's say we have a 1 minute clip of that lecture. So the most important parts of that lectures are extracted. So these are the popular use cases of speech summarization. So speech summarization, the so speech summarization is our perspective. Now, summarization is generally done by when we talk about text summarization, we find out the important information based on the semantic similarities and the how many important words are occurring. So this is how we find it in text documents, in text retrieval. But in terms of speech, what are the ways that we can find the information? So there are two methods. There are two ways each can be summarized. One way, the most common way and the most popular way is converting that spoken document into text using a speech recognition tool. So from the speech, we convert it using an automatic speech recognition system or ASR system into text, and then we use the common methods of finding the most popular words and most frequently used words like we do in text retrieval. We apply the same methods in case of this when we convert the speech into text. But the question that comes is that for low resource languages, for example, for especially Indian languages, which are still low resource, even though we have a huge literary sources and speakers, a huge number of speakers, we still, in terms of information retrieval data sets or technologies, these languages are still low resource, and there are other languages which are low resource. So in for those particular languages, sometimes it's not converting those speech into text is not very reliable all the time, because when we still find in some Indian languages, maybe the automatic speech recognition systems are working well, but they are still error prone. And we cannot assure till now that all the Indian languages are represented well in terms of great accurate speech recognition systems. So when that speech spoken document is converted to text, we have a lot of words, important words, unique words. They are not converted exactly to the text. So in such cases, we have this problem of losing information. We are losing important information, and we are losing. And sometimes the most important words are holding the most unique words, the rare words. They hold they hold more. The significant information into them, but then those are the very words that are not converted to text because of their rarity. So, for low resource languages, to go back to the other method of speech summarization, which is text independent. So, maybe if we look at speech summarization in a way where we don't depend on text at all, we don't depend on converting the speech document into text. So, for such case, there will be a different paradigm or different way of techniques where we find out the important information. So we don't depend on the important words. We depend on how we utter and how we speak, how we present importance. So while I am talking or while any of us we were talking, the importance is presented through the emphasis. So that is what we call prosody. Prosody is the melody of speech. So when I'm speaking, the pitch variation, the loudness variation, they are representing which segments I am trying is highlighted more, which segment of the document. So, for example, in broadcast, in news, let's say, when there is a news, so the aaj ki taza khabar, and this is a breaking news, and some segments are more highlighted through pitch variations and loudness variations. So in terms of when we are not depending on text, we are only depending on how we are articulating or how we are was representing through speech and speech waveform itself, we find that the prosodic features are might hold the proxies of text. So these are the prosodic features for the most basic prosodic. There can be a lot of features to represent prosody. The most basic ones are speech, the pitch variations, and loudness or energy of the speech waveform. And there is one more, spectral features are not really a part of prosodic features, but spectral features are also considered in the terms of, because it takes the raw, the raw details, the raw information of the speech waves. So one example of prosody in the speech wave. So this is just a snapshot. So that is the speech form, and the green lines, the green curves are the intensity, the energy curves. How when the person is speaking, how the energy is modulating, it's different. And the blue lines, right behind the green lines, they are the pitch curves. So for each segments, how the pitch was varying across the sentence while the speaker was speaking. So then the main question, the question that arises is that from the IR perspective, can we rely on prosodic features to extract can we rely on them that they will direct us to find the important segments. So if prosody really reflects that human notion of emphasizing an importance, so it might give us an answer to not completely depend on text. So that is the question, that is the idea that in our research we wanted to explore. So the methodology of this work was basically we have spoken documents of, so it was broadcast news, which was broadcast news of 15 minutes each. So for those 15 minutes broadcast news, they were segmented into sentence units. So 15 minutes broadcast news, it is the entire session of they were speaking of that entire day, that was segmented into units, sentence units. Each sentence audio were represented into their feature vectors. The features are as given, that they were represented as feature vectors, and then we have a data set, and a binary classification was done. So how we got the labels, which sentence is important. So we chose experts, and they handcrafted the summaries. We got the gold standard of which sentence is important, and based on that, we trained the data set, CNN model, and any other classifier we use. In this case, we use a CNN model. It gave us, it predicted which sentence is important, and from there we got the collection of audios, that these audios hold the most important information. Concatenating them, we get the summary. So this is the CNN architecture that was used in this experiment. So in this experimental setup, we focused on two Indian languages, which is Assamese and Bengali. So these two languages, mainly the evaluation was mainly done on Assamese. Assamese is a northeastern, it is a predominant language in northeastern part of India, and Bengali is another language which is predominantly used in India, and also a national language of Bangladesh, and they have a huge speaker base. So the corpus was taken from Akashvani, so from Akashvani Guwahati, and Akashvani Kolkata for the Bengali news. The three feature sets were used to compare which feature set worked perfectly. Prosodic feature set was used, only spectral feature sets were used, and combining them just to see that which feature set is helping more in evaluating or in understanding the information, giving the better performance.
So the choice, why these two languages were used for this evaluation, just to see that whether, since Assamese and Bengali are closely related phonologically, so whether a model trained purely on Assamese, can they transfer well for Bengali data as well? So suppose the model was trained on Assamese data, the model performed well for Assamese data. Now, will this very model, if tested on just Bengali data, will it work well? If it does, so multilingualism, we have a direction for multilingualism, and we can say that Prosody does transfer well. So this was the cross-lingual transfer setup. So the training set was 11 sessions, which was approximately more than average 3 hours, more than 3 hours of data of Assamese news. And for in-language testing, we took three held-out sessions, which was let's say almost 1 hour of test session, and cross-lingual was to see whether the Assamese training model worked well on Bangla. So evaluation was done for sentence classification, whether it properly classified the sentences, and also for summarization. Like so, this the classifiers gave the CNN classifier gave us 4 for each sentence, and based on the summarization ratio, we took the, let's say, the first 10 sentences which were highly scored by CNN, based, and we took those sentences, and that was the summary. So this is the classification performance of the CNN model. It had some over and yes. So this is the summarization performance for in language. So the model which was trained on Assamese data, those models were then tried on the Assamese test set itself. So for prosodic feature set were stable. Spectral feature set, the models which were trained purely only on spectral representation, they performed better. They were stable across. And the combined setup, which was both prosody and spectral features, they worked well all over. But for cross-lingual evaluation, it was the models which were trained on Assamese when they were tried on Bangla, the prosodic models performed better than the purely spectral-based models. The spectral features which were there, prosodic models gave a better performance for, but it gave across the models, and the combined feature set, they were not very reliable. So prosodic features did. So this is the snapshot where we can see that the blue one is the in language and red is the cross-lingual performance. So only prosodic features. So we can see that for in language, depending only on prosodic features were not very didn't give much better performance. But for spectral features, it gave it gave good performance. So the reason behind them is spectral features capture the language. Spectral features are very language dependent. So when it was only about evaluating the in language. So spectral features were able to capture those behavior properly. But for prosody, what happened was that coincidentally the speaking style of Assamese and Bangla were a little different. So in that case, prosody did not transfer. Sorry, for Assamese and Bengali, the prosody of highlighting the important sections that worked well, and for that very reason, prosody models for cross-lingual transfer helped here. So this was the evaluation of prosody, and it does answer the question that prosodic features do transfer well. The limitations of this experiment was this was done on a small data set, and the speaking style did play a more experiments in a diverse data set. And lastly, these are the future directions. More languages are needed to get to be reliably say that yes, prosodic features are the answer, and it does play as a reliable proxy to text. So more languages, more low resource languages, and some richer representation. So maybe after that, the final answer can be found in terms of prosodic, whether it's time to that. Thank you. That is all.
How factual features are different from software?
Yes, sir. Spectral features are not capturing the tone variations. Spectral features are only the mel frequency spectral features. They are only capturing the phonetic structure of it, like e. Those are the ones that the spectral features really capture in the 39 features, let's say, PK. But the prosodic features, the pitch, which we consider the minimum pitch, maximum pitch, average pitch, standard deviation of pitch, and let's say loudness, minimum loud, minimum intensity, maximum intensity, mean intensity. So they are taking they're taking the information how the pitch is behaving, and how this intensity or loudness is behaving. So in that very sense, prosodic features are capturing something else than this what the mel frequency the spectral features are capturing.
Nothing to do with the
No, they're purely speech features. Sir. They're speech features. I will tell you the calculation, exact calculation. The soft. No. The analysis, the visualization was done on Pratt. So Pratt, yes, sir. So that was the analysis, but the algorithm and visualization that was on Python. Yes.
Because Patna is just there. So what does that take them to have a greater direct spectrum towards that? So in that case, we pick up videos or audios from those stages. They might have the top features very different.
And exactly why prosodic models did transfer well.
Yes.
Yes, that is exactly what this research is trying to answer. That since Bangla and Assamese are so related, so probably if Hindi was added to this, for this might not transfer well for let's say Western languages or Tibeto-Burman languages. That's a thought because Japanese or Chinese and their language family they they emphasize in a very different way, in a very dead tone. Let's in this case we are forgetting what we are saying. It's the tone. This is what it means. So Assamese in Bangla and or Hindi and maybe so their tones of describing ki kahan ja rahe ho, kothay jaccho, both goal. So these tones are so similar that brings into question that maybe multilingual this prosodic based model might transfer well. That is the question that we are trying to explore. Yes. Noise reduction, loudness, normalization, all those were done. Extracting the features, the data would have been very.
Okay, so the next presentation is Hello GPT in the active learning with Oracle GPT 3.5 by Anjana.
Hello everyone, I am Vipinka Maurya from IIT Guwahati and I have done this work RSVP reactive learning with Oracle as 3.5 with co-guide as Professor Vijay Sarari and Professor Ashish Anand from IIT. So as the name suggests, Hindi active learning with Oracle as 3.5. So what is active learning? Active learning is a paradigm where we use very small training data to train a model and then we label the unlabeled data on the basis of the same model and add it to the training data in order to get convergence so that we can get easy data labeling because it would be helpful in low resource. So as with traditional active learning, the humans are used as Oracle annotators. But the question is, can we replace the human annotators with the large language models? So we have tried to answer this question in this work. So this is the overview of the presentation, motivation, methodology, results, error analysis, and conclusion. So the motivation was that manually labeling training data is time consuming, expensive, labor intensive, and static. And all these words are self-explanatory, so I can emphasize. And the other motivation that we had was there is one of the paradigm known as programmatic lead supervision. So what this paradigm does is that it noisily annotates the data with the help of label functions and then build some label model to aggregate the noise and we can get performance which is quite good. So our thing was that the labeling functions which were used were depending on the characteristics of the data and the information present in the knowledge bases and categories. So we thought that LLMs are a good replacement for this. So we tried to use the LLMs in place of the labeling function. So this is our methodology. In this, we have this a classifier model. So first we have the small training data, D-labeled. With the help of this, we train a small model. We train a model, and then what we do is we apply this model over a large pool of unlabeled data sets. From that unlabeled data set, we get the data set label, and we then choose the points with the help of sampling techniques. With those chosen points, we give it to the GPT model and get the annotations and then again add to the training data and read a model until we reach up to certain iterations or thresholds or convergence point is reached. So these are the details to the classifier models that we, since it is based on Hindi language, so we use standard classifier models which were available for Heiner, Multigonal and Namapadam languages, which are the most common Indian languages data sets which are available for us. And these were the models. Now, the query sampling strategies that we used for this technique were these: entropy sampling, margin sampling, and least confidence sampling techniques. So, these sampling techniques have different methods of selecting the samples from the data set that are getting labeled to the model. So, entropy sampling chooses the samples that have highest uncertainty measured by entropy. Then, margin sampling, it chooses samples on the basis of the difference between the highest predicted and the second highest predicted point. And least confidence sampling chooses the point on the basis of the annotation where the point has got least least probability of prediction. So then we come to the data set that we use. So these were the data sets. The starting 4 data sets were the primary data sets that we used, because they were all based on the name entity recognition, and the other 2 data sets of Hindi health data and Hindi English code mix data were used to see if LLMs were able to do good task in these, because Hindi English code mix data was of varying domain because it was a code mix domain, and Hindi health data was of varying labels of disease, symptom, and consumption. Now, these were the experiments that we used in our data set. And this was the prompt. I think the slide. This was the prompt that we used. So, this is the one-shot prompt for our initial experiment that we have done. And the results that we achieved were this. The results are not that great, but we can see that for certain common entity types like a person, located in an organization, the models were performing, these LLM models were giving good annotations. But when we go to very uncommon entity types, they were not getting very, they were not giving very good results. And this was the result that we conducted when these data were annotated through humans. So these were good as compared to the data annotated through the LLMs. Now these were certain analysis experiments that we did, and we found out that the least confidence and strategy was giving better performance as compared to entropy and margin sampling technique. And we found out that the least confidence has better prediction over the models. So least confidence exhibits the most stable and high performing trend across all the other models that we use. These were certain experiments that we conducted by comparing the annotations in 3.5 and the human annotated data set, and we can see that the supervised annotated data set gave better performance. And for Hindi health data and the Hindi English code based data, the performances were not good when they were done through the LLMs. Few more experiments were done by using the teacher student. This was one of the experiments that we conducted where we used a speaker student setup in order to see if it did better than the LLMs, and we found out that it did not do good with the compared to the LLMs. And then we also did the India annotated argument with the annotations that we got to the LLMs and the original human annotations that were present. And these are the scores. For Niger, there was average score, and now the also average score. For others, they were not good scores. And these were certain other analysis that we do to see if we increase the seed size and if the performance increase. So if we increase the supervision, then the performance will increase. And these were the certain experiments done to analyze the model performance trends across different sampling strategies for the data set. And we did the error analysis also of the LLM annotations, and we find out these 5 errors, but these were the most common errors. We found out more other errors which are not mentioned in this slide. So this was the tokenization mismatch error, where it could not understand like was a Ban Ki Moon is written. So it used to consider Ban Ki Moon 4 different tokens were given by GPT annotation as compared to the human annotation, where 4 tokens are only considered. Then there were boundary errors like Chini Sarkar, which is one entity, but it gave other to Chini, and Sarkar was labeled as an organization, which is not a good, it is kind of ambiguous. Then there were missing entity errors like it was uncommon entities were not recognized as LLMs. There were spurious entity errors as well, like the entities which are present in the data set in the sentence, but it cannot recognize. And there were type mismatch errors as well. So these, but in the other work, we had tried to resolve these entities, resolve these errors. And in the future work, I would like to say, so in the future work, we try to do this thing. And also, since this was done through GPT 3.5 and it is a closed source model, and it would be quite expensive to use such models. So exploring these type of task with open source LLMs would be a good idea. And thank you. Concludes my presentation.
Any question? In the slide that is in the pipeline, the for the transfer model to be dictated for the LLM table. How do you stop the loop?
So we did some experiments and found out that if the model converges, then we stop it. Or we decided certain threshold value. So if it reaches that threshold value, then we stop. So we did some validation experiments initially and tested.
So, during your training studies,
Yes.
so how are you training your training? What is the
So training
context and
training in academic scenarios is a very small data set where you will have a sentence, but for NER category I'm saying, you'll have a sentence, then corresponding to it, you will have for each token in the sentence, you will have the labels.
all the tokens will have
No, so all the text tokens will have the labels, but the tokens which are not entities will be marked as O. O means others.
I don't think that is reasonable, right? Other can be
See, the task focuses on name mentioned where person, location, organization are the main kinds of entities that we focus on, and O is the other than these entities we don't focus on. So entities.
It's like you have the context. Like, for example, series right? So you put a boundary, maybe
so we don't.
angle brackets, and then you say that it is an
So in the training data, it is mentioned like that. But the LLM, however, it gives annotation, so that won't be compared if it gives that bounded annotation or not.
But then you don't need to actually keep every other.
So we need to give now that how the model should learn that it is other.
Because many words can occur in that boundary which is some other entity. Right?
So
Which has been classified as other in some other.
Okay. No. Okay. It's suppose there is sentence.
Let's say chili circle that is organized, right? But chili is sugar.
So these are the kind of errors that are present in the annotation of the LLM. So chili is sugar. It's a product, but according to person, location, organization, it does not fall in this category. So it will be marked as other.
Could have shown the sample data.
So, but the thing is that the problem that we are trying to focus on is there are three kind of tables in Postgre name indicated that person, location, and organization. Okay. So whatever entity types present in the data set can be named as person, location, or organization. Suppose if we consider this institute that if we take a sentence in Hindi that IIT Guwahati में fire conference हो रही है. Okay. So IIT Guwahati is an organization. Okay. Fire conference here.
What is May? Like IIT 40 May. It is also like a month.
May is a non-entity. It is not an entity. It would be marked as O.
So all other entities you are marking as other.
But the entities which are not falling in the category of person, location, or organization are marked as O.
Are you also removing stop words and also those things?
That is the piece of the screenshot.
But IIT Guwahati May. When May becomes a month and summer it becomes a stop.
May what?
A month.
No. Hindi is
But it's just the
May or month.
the data is in Hindi only.
Yeah, like there could be like math, either.
But
Considering May is a month. Yes, it is not considered because it is actually only now. That's why May.
And the data is Hindi data.
Okay, you were thinking that
context also.
Yeah.
Any other?
Okay. So now, like, we break, then.
Yeah, so that brings closer to this last session of the fourth day, the conference, as well as closer to the 4 day long higher, I say, conference. So, this is the exploration. Again, we have been constantly giving you which instructions. Sometimes might have been removed or not be accepted. Sometimes also situations sometimes been very unacceptable. Okay, because of weather, because of other calamities like cancellation, and the latest one of our so you can go for tea, but we'll be here to hear you out. Okay, we are all here. Yeah, your show. Okay. Our team, you can bring the insight and bring the energy. There are any suggestions, in comment, contribution of our, as well as, feedback that is related to our organization. Thank you all for the session.
There was a while, like, what, yeah, 30. Yes.
The first thing we had to do was the first thing was to get by the UCR and the Sarkar's.
Yeah, 6 years. Right. So the
Like 7 or 8 of whether it's normally 7 way. Yeah, I recommend get this. For cloud, we will be